Very good morning all. Okay, I think all of you joined. Let's start. Okay. What we saw in the last class? So we are looking for the solution for the system of linear equations, right? So we saw in mathematics, right? System of linear equations in the sense while considering the systems, there are two type of systems, right? One is called homogeneous system and another one is called non-homogeneous system, and simply we saw the difference between them, right? And I had been told you, right? I have given a small request just to see the difference between trivial and non-trivial solutions. I don't know how many of you have seen that one, but anyway, let's continue our lecture. So yesterday I took some examples based on non-homogeneous systems, right? Non-homogeneous system in the sense Ax equal to B, right? We are also considering some set of input signal and then we are driving the system in order to obtain the result and desired value, right? Fine. So in non-homogeneous system, what is the conclusion here? So when we are looking for non-homogeneous system, there are three possibilities. First thing is, while considering a system, ஒரு சிஸ்டம் எடுத்துட்டு அந்த சிஸ்டம்லயே நம்ம இன்புட்டை பாஸ் பண்ணும்போது மெய்தர் அந்த சிஸ்டம் வந்து நீங்க பாஸ் பண்ற இன்புட் சிக்னல் அக்செப்ட் பண்ணலாம் இல்ல பண்ணாமையும் போகலாம், ரைட்? ஸோ there are two possibilities. ஸோ அப்போ அங்கிருந்து நம்ம என்ன பண்ணா, so whenever I'm testing a system டெஸ்ட் பண்ணும்போது there are two possibilities. Either that system might provide some solution or it may not provide any solution, right? So there are two possibilities. Now under that category, if there is no solution in the system, then we can just leave it, right? And we can write these statements for the given system, we cannot write any solutions, right? Suppose second case will be there, that is called what? Solution will exist, but if your solution exists ஆகுது அப்படினா என்ன மாதிரியான possibilities நம்ம எக்ஸ்பெக்ட் பண்ணலாம்? There are two type of solutions, right? One is called unique solution and another one is called infinite number of solution. So in engineering, that is in algebra, we are going up with some type of conditions, right, in order to bring out the linear solutions, right? That is solutions for linear equations. We are defining some set of rules, right, in terms of matrix, right? Let me recollect all those things and then I will take homogeneous system also. We will discuss all these things one by one, right? So let us take once again. Anyway, yesterday I concluded all those things. I am just recapturing once, right? So first your system of linear equations, that is solution for the system of linear equations. There are two type of systems, I said, right? One is called homogeneous system and second what we saw, there is one more type of system, that is called what? Non-homogeneous system. Another one is non-homogeneous system, right? Whereas homogeneous system can be represented as A into x equal to 0. Non-homogeneous system in the sense your system will be tested by some input signal. Now in homogeneous system, your system will always, homogeneous means that system will always have certain number of solution. No solution அப்படிங்கிற term எதுல வராது. In homogeneous, there is no term is called no solution. Whereas in non-homogeneous system, we have two type of solutions, right? I said either your system might provide no solution or you can expect some solution from your system, right? That solution. Suppose if your system is providing solution, then that solution will be classified into two types. Let us see. In homogeneous system, we will always have certain solution. That solution can be classified into two types. I said one is called trivial solution and another one is called non-trivial solution, right? Another one is called non-trivial solution, right? I think yesterday I have given some conclusions, right? So the thing is, trivial solution in the sense we should talk about non-singular matrix, right? Trivial solution in the sense we should talk about non-singular matrix, whereas non-trivial solution in the sense we should talk about singular matrix. Okay, let's see, right? Beyond these things we will demonstrate all those things one by one. Keep your attention. Next when we are looking for solution and no solution, here also under solution there are two type of solution, right? One is called unique solution One is called unique solution and another one is called infinite solution. Guys, I said its application is very vast, right? So you can expect each and every year, whichever the exam that you are facing, at least you can expect minimum one question from this area because that is very important, right? So keep your attention. Unique solution in the sense, let us see. Now, that is solution in the sense we can expect two type of solution, unique solution and infinite number of solution. So the conclusion is system of linear equations, right, can be classified into two categories, right? One is homogeneous, another one is non-homogeneous, right? Now, when we are entering into homogeneous, when there is no term is called B, that is input signal will be 0. Whereas non-homogeneous in the sense your system is being driven by some input signal. Under that category, we saw there are two conditions. Now, you are supposed to find out the rank of A, matrix A would rank. We have to find out the rank of A. And I am also supposing you to find out the rank of A argument with B. If these two people will become equal, then the given system will provide some solutions. Suppose if rank of A will become not equal to the value of rank of AB, such sort of systems never allowed you to get any solutions, right? That is called a no solution, right? Simply, okay sir, since rank of A and rank of AB become equal, then how can I expect? Okay, that system will provide some solution. I don't know whether the given solution is going to be, that is the solution that we are obtaining is unique solution or infinite number of solution. That is not known, right? In order to obtain the next condition, in order to test whether the given system will provide unique solution or infinite solution, the next condition is, right, already two conditions can be satisfied. One is rank of A and rank of AB will become equal. And if it is become equal to number of unknown vectors, I said number of vectors, variables or number of unknown vectors, then that system will provide unique solution. When you are looking for infinite solution, in case of infinite solution, of course rank of A definitely will become equal to the value of rank of AB, but I said its resultant total value will become less than number of vectors. If it is less than number of unknown vectors, then that system will provide infinite number of solution. Getting back to the conclusion here, similarly, when we are looking for homogeneous system, right, I hope you all have seen the difference between trivial and non-trivial solution. See, trivial in the sense that system will provide only one set of solution, that is, all your vector variables are going to be equal to 0. That is the one only solution that you can expect in case of trivial system, right? So, vector variable is going to be equal to 0 and non-singular matrix, your selected matrix, see, we have only one matrix. And that matrix is defined as non-singular. Non-singular in the sense, if you are finding, let me conclude. If you are finding determinant for this matrix, then the determinant will become not equal to 0. That is, what do I mean by non-singular matrix? Whereas, you will have only one solution, that is called a trivial. Trivial in the sense, all vector variables are going to be equal to 0. Here, right? Non-trivial in the sense, that system might provide n number of possible solutions. N number of possible solutions could be available here. Okay, that is in case of non-trivial, many possibilities, right? Fine. So singular matrix in the sense determinant of the matrix will become equal to 0. Now already I had given some set of conclusions when I was talking about determinant of the matrix and rank of the matrix. ஒரு மேட்ரிக்ஸ்க்கு நீங்க டிட்டர்மினன்ட் ஃபைண்ட் பண்ணும்போது டிட்டர்மினன்ட் வந்து நாட் ஈக்குவல் டு 0 வருது அப்படினா that matrix rank can be defined as, that is equal to what? Rank order of the matrix. See, suppose if you selected matrix as the order of 2 cross 2, then how many vectors are there? 2 vectors. But in 2 cross 2 matrix எடுக்கிறீங்க அப்படினா how many unknown vectors could be possible for that? ஒரு 2 cross 2 matrix எழுதுறீங்கன்னா அது கூட நீங்க எத்தனை unknown vectors கன்சிடர் பண்ணுவீங்க? x1, x2. Similarly, if I will consider 3 cross 3 matrix, then I will consider 3 unknown vector. For 4 cross 4 matrix, you consider 4 unknown vector. Like that, the conclusion is, if the determinant is not equal to 0, then it clearly denotes that the value of rank of the matrix will going to be equal to, rank of the matrix will be equal to order of the matrix, right? Whereas, order of the matrix is going to be equal to number of unknown vectors, right? Now, how many unknown vectors that we are going to consider here? See, that is depends on the system that we are choosing. For example, here I can say number of unknown should be equal to number of unknown vector variables. Clear? Guys, 1 second. Sorry for the interruption. Okay, let us continue. Listen, I am repeating once again. determinant not equal to 0 அப்படினா அந்த matrix ஓட rank எவ்வளோ? matrix ஓட rank of the matrix should be equal to order of the matrix, whereas order of the matrix equal to number of unknown vectors. Such that I can say directly I can define rank of the matrix should be equal to number of unknown vectors. I can say number of unknown vectors. So the conclusion is directly if the rank of the matrix and unknown vectors are equal, then that system will provide trivial solution. Suppose second case, non-trivial solution in the sense when we are looking for the rank of the matrix, right, that will become, see, determinant is equal to 0. அப்ப நான் condition என்ன கொடுத்தேன்? Determinant equal to 0 அப்படினா while finding the rank of the matrix, that matrix should be what? Its rank of the matrix should be less than n, where n denotes the order of the matrix, but least value could be what? 1. Clear? That is the procedure, right? That things I have given proof also, right? So the conclusion is what? Rank of A should be less than n. N is nothing but what? N is equal to number of unknown vectors. So I can replace it by number of unknown vectors. Number of unknown vectors. So the conclusion is what? If the rank of A, let me write the statement. Rank of A is less than number of unknown vectors, then that system will provide non-trivial solution. Guys, very important observations that I am giving here, right? Please don't forget, because this is very important zone. I said its application is very vast, because we are looking for the solution of system of linear equations. Almost, right, whichever the quantities or systems that we are designing in this universe, right, all the systems we are giving some restriction. Whichever the things, for us we are providing some linearity. We are not acting as a non-linear system. Actually we are not linear only, but we are giving some restriction. See that every day we are continuously attending the classes for some 2 hours, at least for some 2.5 hours or 3 hours. That process is continuous, you know. We are providing some restriction. I have to attend the classes during that particular time period. I have to take the classes during that particular time period. Like that, at particular time period we are spending some time to take food. Like that, some particular time we are spending in order to take rest. Like that, some linearity we are always giving, right? So that is we are following. That is called, in the sense, what is the conclusion here? In this universe, whichever the system that we are designing, that systems mainly, and the system வந்து design பண்ணும்போது நம்மளோட concentration எப்படி இருக்கும் அப்படினா அந்த system வந்து linear-ஆ வர மாதிரி தான் நம்ம டிசைன் பண்ணுவோம் with some restriction. இந்த பாயிண்ட் தாண்டி போனீங்கன்னா அந்த system வந்து non-linear ஆயிடும். Like 8 hours நீங்க தூங்குனீங்க அப்படினா okay, that will be good for your health. 6 hours moderate, tolerate பண்ணிக்கலாம். If you go 4 hours or 3 hours அப்படினா automatically your brain started affected. Opposite case, 8 hours தூங்குறதுக்குள்ள 12 hours தூங்கினோம்னா automatically laziness will increase, right? So the conclusion is what? We should provide some restriction, marginality. 6 to 8 hours is the marginal time period in order to take rest, right? So like that, for each and every system will have certain linearity zone, right? So what is the conclusion here? Application of this linear system is very vast in this universe. That's why I am looking for, what I can say, whichever the exams that we are looking, definitely we will expect some priority will be given to this chapter in this area, right? So should try to understand all these things. That's very important. Okay, I hope you all have understand the logic behind of this. Let us take some example. Let me demonstrate, right, such that you will get the very clear idea, right? Fine, right? Make very clear notes. Now while solving the problem, you will come to know, right? You will get the idea, right? Yeah, let me rub these things. Let us see the solution for this one. Now we can take homogeneous system, non-homogeneous system, any systems that we want, right? Yeah. Because yesterday we saw some set of systems, right? Fine. Now let us take the next example. Once again, let us consider example number 1, right? From here. Now we shall consider some 2 plus 2 matrix, right? Let me take 2, 4, 3, 2, right? Now let us see. And it's given as x1, x2 equal to 0. We all know this equation can also, actually we are bringing matrix from set of linear equation only. Either wherever you belong, it can also be written as twice of x1 plus 4 times of x2 equal to 0. Similarly, 3 times of x1 plus 2 times of x2 equal to 0. That is also correct. That is another way of representing system of linear equation, right? From that we are bringing the matrix, right? Fine. What is the next target? First, keep your attention with the matrix A. Here, my matrix A is 2, 4, 3, 2, right? Now, what is the conclusion? First, tell me whether the given system is homogeneous system or non-homogeneous system. That is homogeneous system. Why? Because on the RHS, I don't have any values. That is, my matrix B is going to be equal to 0. So I can say, since matrix B is equal to 0, so the given system is homogeneous system. First conclusion is, given system is homogeneous system, right? For your homogeneous system, we will always have certain solution. Yes or no? Homogeneous system பொறுத்த வரைக்கும் no solution அப்படிங்கிற word possibility கிடையாது. நான் clear சொல்லிட்டேன். Homogeneous systemக்கு நம்ம input signal எதுவும் கொடுக்க மாட்டோம். அந்த சிஸ்டமோட பிஹேவியர் வந்து நம்ம செக் பண்ணி பார்ப்போம். அதுக்குள்ள இருக்க சொல்யூஷன்ஸ் மட்டும் நம்ம அப்படியே எடுத்து பார்ப்போம், right? Like that, always in the homogeneous system you will have certain solution. There is no term is called no solution. அப்படிங்கிற word இங்க வரவே வராதுங்கற, right? So, solution in the sense we can expect two type of solution that system might provide, right? Might you can expect trivial solution, right? Either you can expect trivial solution or you can expect non-trivial solution, or you can expect non-trivial solution. I said trivial solution in the sense we should consider non-singular matrix, right? When we are looking for non-trivial solution, we should consider singular matrix. Very important. Otherwise, simply remember, in case of trivial solution, what I have been told you, we have to non-singular matrix in the sense determinant of the matrix is not equal to 0. If it is not equal to 0, then I can say rank of the matrix should be equal to number of unknown vectors, or we can say order of the matrix. Whereas here, rank of the matrix should become less than number of unknowns, right? That is order of the matrix or less than number of unknown vectors. Clear? Now that is the conclusion in order to obtain the solution for homogeneous system. அப்ப நம்ம இப்போ என்ன செக் பண்ணனும் first? அப்ப இந்த homogeneous systemக்கு நீங்க first செக் பண்ண வேண்டியது என்ன அப்படினா determinant. You have to find out the determinant. அதோட வேல்யூ வச்சு தான் இந்த சிஸ்டமோட சொல்யூஷன்ஸ் நம்ம கெஸ் பண்ண முடியும், right? Let us proceed further. Find out the determinant of this matrix. Determinant is what? 2 into 2, 4, minus 3 into 4 will be 12. So 4 minus 12 will be equal to minus 8, but it is not equal to 0. Do you agree? Yes. If determinant of the matrix is not equal to 0, then what is the conclusion? Rank of the matrix should be equal to number of unknown. If rank of matrix should be equal to number of unknowns, then that system will provide only trivial solution. That system will provide only trivial solution, and in that case I said all the vector variables x1, x2, etc. all are equal to 0. Only one solution, that is equal to 0. Clear? That is the one and only expected solution when your system will provide you trivial. Okay, let us take the second example, right? Let me take second example. Let me rub this one. Let us take the second example. Slowly understand, because it's very easy, right? By practice, automatically, just by looking the questions, you will come to know how to bring the answer, right? Yeah. Let us take this some another example. Let us consider 3 times of x1. Let me consider some what shall I consider? 2 times of x2 equal to 0, right? Now I am going to consider one more value. Let us consider 4 times of x1, right? Not 4. Let me consider 6. 6 times of x1 plus 4 times of x2 equal to 0. Let us write the matrix for this. If I write this one in terms of matrix, it is become 3, 2, 6, 4. That is the coefficient of my eigenvectors, whereas eigenvectors can be defined as x1, x2, and it should be equal to 0. Is it homogeneous or non-homogeneous? Obviously, given system is homogeneous. Why it is homogeneous system? Why? Because since matrix B equal to 0. From that I can define the given system is homogeneous system, right? And the next conclusion is we should find out for a homogeneous system. Once again I told you, if your system is homogeneous system, then there are two possibilities, right? Possibility number 1, the system might provide trivial solution, or your system might provide non-trivial solution. Now when we are looking for trivial and non-trivial solution, in case of trivial, your matrix is called non-singular matrix. When we are looking for non-trivial solution, we have to consider singular matrix. Why I am writing again and again? Because you have to register these things into your mind, right? So non-singular matrix in the sense determinant of the matrix should be not equal to 0. Singular matrix in the sense determinant of the matrix should be equal to 0. In case of non-singular matrix, we all know rank of the matrix should be equal to order or number of unknowns, whereas in case of singular matrix, rank of the matrix should be less than, wait a minute, I put determinant instead of rank, that is going to be less than n. We know these things? Yes. Let us proceed. Find out the determinant of the matrix. 3 times of 4 will be 12, minus 6 into 4, 2 also will become 12 equal to 0. What I have understood? See, for a matrix, if your determinant is equal to 0, then the rank of the matrix can be defined as, we all know, it is what? Less than or equal to, that is 1 to less than n, not equal, less than n. Do you agree? Yes. Do you agree? Yes. So the conclusion, because determinant is equal to 0. So such a type of matrix is called what? That is called singular matrix, right? So this matrix is called singular matrix. This matrix is called singular matrix. Anyway, can you find out the answer for this one? Answer is what? Rank of the matrix should be equal to 1 only. Why? Because since the order of the matrix are number of unknown vectors, only 2 unknown vectors are there. இப்போ rank of A ஓட வேல்யூ வந்து less than 2 இருக்கணும்னு சொல்லிட்டேன். less than 2 இருக்கணும் அப்படினா என்ன பாசிபிலிட்டி வரலாம்? It cannot be 0. less than 2 ல ஒரே ஒரு பாசிபிலிட்டி தான் இருக்கு, 1 மட்டும் தான், right? So at least it is equal to 1 only, right? So the rank of the matrix should be equal to 1, whereas number of unknown is 2. So both are not equal, right? Or I can write the relation, right? So since the rank of A is less than n, if rank of A is less than n, then such sort of system will provide non-trivial solution, or I said many solution, right? It is also called what? Many solution. Possibility of, there might be a possibility of getting many solutions for the given system. Clear? So that is how we are getting answer for homogeneous systems. Test very simply will be tested. இப்போ பாருங்க, நீங்க அப்படியே மைண்டே போட்றீங்க, இத பார்த்தோனே தெரிஞ்சிரும் இதோட டிட்டர்மினன்ட் 0 இல்ல நாட் ஈக்குவல் டு 0 அவ்வளவுதான். டிட்டர்மினன்ட் 0 ஆயிடுச்சு அப்படினா சிஸ்டம் வந்து நான் ட்ரிவியல், அவ்வளவுதான். டிட்டர்மினன்ட் நாட் ஈக்குவல் டு 0 னா சிஸ்டம் ட்ரிவியல். How many minutes will take? How many seconds will take for this? Just to look at the question, 3 seconds or 4 seconds you can pick the answer, but you have to remember, right? Fine. Let's take some other examples. Let me rub these things. Let us consider some other examples, right? Slowly you should try to keep your attention here. One second. Yeah. Fine. Let us take some other examples. Other examples in the sense, let me consider some 2 into x1 plus 3 into x2 plus 4 into x3, right, equal to, let us consider 3. Now let me consider 3 times of x1 plus 2 times of x2 plus 2 times of x3 equal to, let us consider 4. Now only these two equations are given. Now the question is, you are requested to find out the system of, so that is linear solution for system of linear equation, right? Whether it is going to be no solution or infinite number of solution or unique solution or 2 solution, 3 solutions அப்படிலாம் கொடுப்பாங்க. ஆனா 2 3 எல்லாம் எப்பவுமே வராது, right? Either no solution வரலாம், unique solution, infinite solution, only 3 cases, right? Yes. Fine. Shall we start? Yes. Our journey is, I have to write this expression in matrix first of all. Let us write the matrix A. Coefficient of x1 is 2, coefficient of x2 is 3, coefficient of x3 is 4. Coefficient of x1 is 3, coefficient of x2 is 2, coefficient of x3 is 2, right? Such that its corresponding vector variables are, wait a minute. Actually, here, can you guess it? Guys, listen, how many variables are here? The thing is, I have x1, x2, x3. 3 unknown variables are there, right? So, one second, I forget to consider one more equation here. 2x1 plus, let us consider x2, let us consider 3x3, okay, equal to, let me take some other value. How many variables are there? x1, x2, x3. Then the vectors will become what? 3 cross 3, right? Let us see. Okay, what shall we do now? Let me write the answer for this one. 2, 3, 4 and 3, 2, 2, 2, 1, 3. Yes, its corresponding unknown vectors are x1, x2, x3, exactly, and it should be equal to various matrix B 3, 4, 2. Yes. Now what is the target? We are requested to find out the solution for the system of linear equation. What shall we do? Right, see, since given it is what? First conclusion, given it is non-homogeneous system. Why it is non-homogeneous system? Can anyone tell me the answer? Because in this given case, A into x equal to b. We are driving the system with some input signal. Just remember like this, right? So for your homogeneous system, non-homogeneous system, there are 2 possibilities. Either you might get no solution, but the condition is rank of A should be not equal to the value of rank of AB. Clear? Similarly, second case, here there are 2 cases. Either you can get, right, if you have solution, then there are 2 possibilities. Either you can get unique solution or you can get infinite number of solution. Now in order to obtain unique solution, the condition is rank of A should be equal to rank of AB should be equal to number of unknown vectors. When we are looking for infinite number of solution, rank of A should be equal to rank of AB should be less than number of unknown. This is the condition. Shall we proceed further? Yes. Anyway, the target is what? First we have to find out the rank of A, rank of AB. Can you please find out the rank of A? This is my rank of A, right? In order to find out the rank of A, first let me proceed. First we have to find out the determinant of 3 cross 3 matrix for this one. If I find the determinant, then that is what will happen? Determinant is going to be 2 into 6 minus 2 will give you 4, minus 3 into 9 minus 4 will give you 5, plus 4 into 3 minus 4 will give you minus 1, right? Such that it is going to be 8 minus 15 minus 4. So what I am getting here, minus 15 minus 4 will become minus 19, minus 19 plus 8 will give you minus 11. Anyway, that is not equal to 0, that is what I want. If rank of matrix A is not equal to 0, then we all know rank of A should be equal to number of unknown vectors, right? What is the number of unknown vectors? x1, x2, x3, or we can say number of rows, right? How many rows are there? 3. So the rank of the matrix A is equal to 3. First we found rank A, right? So let me register somewhere here. Rank A of the matrix is equal to 3. What is our next task? We have to find out the rank of AB. To obtain the rank of AB, we should club them together. Yes, let me club them together such that let us see the solution for rank of AB, right? So for that, let me rub this one, right? So let us rub all these things, right? Yeah, let us find out the solution for rank of AB. Can you please do it for me? Because you all know the procedure. Yesterday also we saw some examples, right? I took some examples and I brought the solution for them, right? So you can repeat them and you can repeat that procedure to bring out the answer. Let us bring out. I am writing augment, that is A augmented with B. I am just clubbing them together, right? So when we are clubbing them together, what will happen? We are going to get 2, 3, 4. In the second row we are going to get 3, 2, 2. Third row we are going to get 2, 1, 3, and then yes. Here I am going to get 3, 4, 2, yes, and let us rub these things. Now what we are going to do, the thing is we have to find out the determinant of this matrix. Sorry, now we have to find out the rank of this matrix. Rank of find out, we need to know the determinant of the matrix. But what is wrong with this? Since given it is, what is the order of this matrix? 1, 2, 3. Number of rows are 3. What about the column? 1, 2, 3, 4. We have 4 columns. That is non-square matrix, or we can call it as rectangular matrix. I told you how to find out the rank of rectangular matrix, right? In method number 1, we said there are 2 methods. Either you can go with the echelon form or you can go with the ordinary procedure that I taught already, right? So let us see how to bring the solution in the method number 1. I told you we have to select the maximum order of sub-square matrix. ஒரு non-square matrix கொடுத்திருந்தாங்க அப்படினா அதுக்குள்ள maximum sub-square matrix வந்து sub-square matrix வந்து நீங்க கொண்டு வரணும், right? So இதுல maximum sub-square na we can go up to 3 cross 3. Do you agree? Yes. Maximum I can select 3 cross 3. You can select any one possibility. Either you can go with this 3, or you can go with this 3, or you can go with 1, 2, 3, this one, like that, right? Find out the determinant. But we all know in the setting நம்ம determinant find பண்ணோம் அப்படினா இந்த first 3 columns க்கு நீங்க determinant find பண்ணீங்க அப்படினா this will give you, right? So here its rank will be equal to minus 11. Just now I have been calculated. Now what I have been told you, இப்போ இந்த காம்பினேஷன்ல ஏதாச்சும் ஒரே ஒரு 3 cross 3 determinant value வந்து not equal to 0 வந்துட்டாலும் that entire system is what? Non singular only. So I can write this statement from here directly. So what is the conclusion that we are observing? The conclusion is ஒரு non homogeneous systemல matrix A வந்து non singular இருக்கு அப்படினா AB யும் non singular தான். By are you getting me? A வந்து நான் சிங்குலர் அப்படினா இதுக்கு நீங்க B ஐ கிளப் பண்ணதுக்கு அப்புறமா என்ன இருக்கும்? இது நான் ஜீரோனா இதோட டிட்டர்மினன்ட் நாட் ஈக்குவல் டு 0. இதோட டிட்டர்மினன்ட் நாட் ஈக்குவல் டு 0 வரல அப்படினா எந்த ஒரு ரோவும் கம்ப்ளீட்டா 0 ஆகலன்னு அர்த்தம். ஒரு ரோ வந்து கம்ப்ளீட்டா 0 ஆனா மட்டும் தான் அந்த ரோவை நம்மால எலிமினேட் பண்ண முடியும். From the then only rank of the matrix will be reduced. இப்போ என்ன ஆகுது, இதோட மீனிங் என்ன? நான் சிங்குலர் மேட்ரிக்ஸ் அப்படினா அப்ப இதுல இருக்க மூணு ரோவுமே எந்த ஒரு ரோவுமே இதுல கம்ப்ளீட்டா 0 ஆகல அப்படி அர்த்தம், ரைட்? அப்ப இது கூட இன்னொரு லைனை இன்சர்ட் பண்ண மட்டும் என்ன? நான் என்ன சொன்னேன், ரேங்க் ஆஃப் ஃபைண்ட் பண்ணும்போது நீங்க 4 வேரியபிள் இல்ல 100 வேரியபிள்ஸ்ல ஒரே ஒரு வேரியபிள் வந்து நாட் ஈக்குவல் டு 0 ஆ இருந்தாலும் அது நான் ஜீரோ ரோ தான். ஒரு 100 வேரியபிள்ஸ் இருக்கு சார், அதில் 99 வேரியபிள் ஜீரோவாக இருக்குது, பட் ஒன் வேரியபிள் இஸ் நாட் ஈக்குவல் டு ஜீரோ. அப்போ அது நான் ஜீரோ ரோ தான், அது ஜீரோ ரோன்னு நீங்கள் கன்சிடர் பண்ணக்கூடாது. சச் தட் இட் கிளியர்லி டினோட்ஸ், பார்ட் 1 கிளியர்லி டினோட்ஸ் இட் இஸ் நாட் ஈக்குவல் டு ஜீரோ. அப்படின்னா இதில் இருக்க 3 ரோவும் நாட் ஈக்குவல் டு ஜீரோ. அப்போ இந்த ரோ கம்ப்ளீட்டாக ஜீரோவே ஆனாலும், இங்கே இருக்க வேல்யூ ஜீரோவே ஆனாலும் ஐ நோ நீட் டு பி பேனிக். வை? பிகாஸ் இங்கே இருக்க ரோவில் கண்டிப்பாக ஏதாச்சும் ஒரு வேல்யூ வச்சு நாட் ஈக்குவல் டு ஜீரோவாக இருக்கும். சச் தட் தட் என்டையர் ரோ இஸ் நான் ஜீரோ ரோ ஒன்லி. What is the conclusion? If A is non-singular, automatically AB also non-singular, right? So the statement is, if A is non-singular, அப்ப நீங்க பயப்படாம டைரக்டா சொல்யூஷன் எழுதலாம். If A is non-singular, then A augmented B also non-singular. Clear? Guys, all our observations, one thing you have to register into your mind. From engineering math, that is linear algebra, you will be tested for lot of theoretical questions. I am repeating once again, right? If you don't remember the properties, nothing is there in maths. எதுமே இருக்காது. ஆனா சின்ன சின்ன விஷயத்தை தெளிவா நீங்க புரிஞ்சு வச்சிருக்கணும். That is what I want, right? Then only out of 10 definitely you can get 10. It is not like your core subject. ஏதாச்சும் கான்செப்ட் மறந்துட்டு ஃபார்முலா மறந்துட்டு ஆன்சர் வரணும். மேத்தமெட்டிக்ஸ் அப்படி இருக்கவே இருக்காது. டைரக்டா நீங்க அப்படியே அப்ளை பண்ணி ஆன்சர் கொண்டு வரலாம். Out of 20 directly you can get 20 marks, right? There is no point of reduction in the marks or negative marks at all. Okay, fine. So if A is non-singular, automatically AB also non-singular. That is the conclusion. So what is the conclusion here? So I can say, அப்ப rank of A and rank of AB equal னு சொல்லிடலாமா? ஏன்னா எனக்கு rank of A என்ன வந்திருக்குன்னா rank matrix A வந்து non-singular. அப்ப AB non-singular தான். அப்ப rank of A rank of AB equal தான். First statement. But this is not enough for me. First conclusion இது நான் homogeneous னு ஃபைண்ட் பண்ணோம். அடுத்து இந்த சிஸ்டம்க்கு வந்து சொல்யூஷன் வருது அப்படிங்கறத ஃபைண்ட் பண்ணிருக்கோம். Because solution எப்போ வரும்? When rank of A will become equal to the value of rank of AB. That is the point where we have started driving solution, looking for solution. But in the solution might be unique or infinite இருக்கலாம். அத நம்ம செக் பண்ணனும்ல. Anyway, already we found what we found, non-singular matrix என்ன ஃபைண்ட் பண்ணிருக்கீங்க. Happily you can write for a non-singular matrix what is the how many non-zero rows are there? 3 non-zero rows. Or I told you, if you have non-square matrix, ஒரு non-square matrix வருது அப்படினா, guys wait a minute, let me write these things clearly. First நம்ம மேட்ரிக்ஸ் A வை மட்டும் எடுத்தப்ப நமக்கு கிடைச்சது ஸ்கொயர் மேட்ரிக்ஸ். மேட்ரிக்ஸ் A க்கு மட்டும் நீங்க தனியா ரேங்க் ஃபைண்ட் பண்ணீங்க இல்லையா? அப்ப நமக்கு என்ன வந்தது அப்படினா, rank of A ஓட வேல்யூ வந்து that is directly I can write that should be equal to order of the matrix. Order of the matrix is 3. ஸ்கொயர் மேட்ரிக்ஸ் தான. ஸ்கொயர் மேட்ரிக்ஸ்ல நீங்க எப்படி எழுதுவீங்க? டைரக்ட்டா ஸ்கொயர் மேட்ரிக்ஸ்ல 3 cross 3 you can consider 3 as your answer. But AB பாருங்க, AB is non square matrix. அப்ப இதுக்கு நீங்க எப்படி எழுதுவீங்க? It should be equal to, right? It should be equal to minimum value of, right, number of rows comma number of columns. Here minimum, that is 3 comma 4. Appo what is the answer? It should be equal to 3. First we have to write this statement clearly, then automatically it will be satisfied when we have non singular matrix. So rank of A, rank of AB are going to be equal to 3. Now how many unknown variables are there? If it is since it is 3 cross 3 matrix, so its correspondent unknown variables are x1, x2, x3. So totally we have 3 unknown variables. So it is equal to number of unknown vectors. So the conclusion is what? Rank of A, rank of AB, number of unknown vectors all are going to be equal, such that the given system will going to provide unique solution. So the correct answer for your given system is, right? So the correct answer is unique solution. Our system will going to provide unique solution. Our system will going to provide unique solution. I hope things are very clear to you all. Clear? Yes. Let us looking for some other models such that you will get very clear idea, right? It's very easy, very easy. First understand the things, right? Because in maths only you have to understand the concepts. If you don't understand, rewatch the video, right? No problem. Fine. Next time let us take some other example. Now I will tell us, let us take x1, right, plus 2 into x2. Let me select x3 equal to, let us take some value 2, and let us go ahead, twice of x1 plus 4 times of x2, 2 times of x3. Let me select some other variable, right? Let us go ahead, let me take 3 times of x1 plus 2 times of x2 plus x3 is equal to, let us take 2. That's enough. Okay, now that is the given. Now we have to find out the solution for the system of linear equation. Shall we start? Yes. Our journey is, first we have to find whether the given system is homogeneous or non-homogeneous. It's clearly denotes matrix A exists, number of vectors, unknown vectors will exist, matrix B also exists. So given it is what? Non-homogeneous system, right? So let us write matrix A 1 2 1, matrix the second row 2 4, 2 coefficient, third row 3, 2, 1. Let us close them, and its corresponding vector variables are x1, x2, x3, whereas on the RHS we are going to consider the variables as 2, 3, 2. Exactly. Fine. What is our target? We have to find out the rank of the matrix. Why? I found Ax equal to B in order vandale non-homogeneous na find panniten. Now our target is either this system will going to provide solution or not. Adu namakku theriyum. So first test step we have to find out the rank of A, rank of AB. Where is rank of A? This is my rank. That is matrix A. Matrix A ku mattum rank find pannalama. Sorry, determinant find pannunga. Determinant of A equal to, right, 1 into 4 minus 4 will be 0. Yes. Minus 2 into 2 minus 6, right, will give you minus 4. Am I correct? 2 minus 6 will give you minus 4. And then plus 1 bracket it grows 4 minus 12, right? So 4 minus 12 it will provide minus 8. What you have understood here, minus into minus will become plus 8. Plus 8 minus 8 equal to 0. What's wrong with this? Rank of the matrix A is going to be equal to 0, right? If determinant of the matrix equal to 0. Determinant of the matrix A, I am just targeting matrix A alone. Matrix A oda determinant வந்து 0 ஆயிருக்கு. அப்ப conclusion என்ன அப்படினா that given matrix is singular matrix, right? If our matrix is singular matrix, then what will be the conclusion? Then rank of the matrix can be defined as less than n, and it should be what? That is, it's starting from 1 and it is go up to n. Yes, I am really very happy. Let us try. We have to find out the rank. Now n is nothing but order of the matrix or number of unknown vectors. What will be the order of the matrix? 3 cross 3. So it is going to be 3. அப்ப rank of A oda value என்ன வந்திருக்கு? It is less than 3. அப்ப என்னவா இருக்கலாம்? Either it might be 2 or it might be 1. There are two chances. அப்ப நீங்க என்ன பண்றீங்க? Subsquare matrix எடுத்து அதுக்கு determinant find பண்ணுங்க. Subsquare எடுத்துக்கலாமா? Subsquare 2 cross 2 matrix. இதுக்குள்ள இருக்க எல்லா possible 2 cross 2 matrix எடுத்துக்கிட்டு அதோட determinant நம்ம ஃபைண்ட் பண்ணும்போது ஏதாச்சும் ஒரே ஒரு 2 cross 2 matrix ஓட determinant not equal to 0 ஆ வந்தாலும் இந்த rank இந்த சிஸ்டமோட matrix ஓட இதோட rank வந்து எவ்வளவுனா 2. Suppose இதுக்குள்ள இருக்க எல்லா 2 cross 2 matrix ஓட possibility வந்து determinant of all possible 2 cross 2 matrix is equal to 0 அப்படினா rank of the matrix will be reduced to 1. That's all. Clear? So anyway, find out the 2 cross 2 matrix. I said ஏதாச்சும் 1 or 2 matrix subsquare 2 cross 2 matrix ஏதாச்சும் ஒரு இல்ல ரெண்டு காம்பினேஷன் எடுத்து நீங்க determinant find பண்ணும்போது ஆன்சர் வந்துரும். Let's proceed. 4 minus 4 0. 4 minus 4 0. 4 minus 12 not equal to 0. What is the conclusion? I am selecting these 2 cross 2. இதுல பாக்கும்போது எனக்கு என்ன இருக்குனா 4 minus 12 is not equal to 0. ஒரே ஒரு 2 cross 2 matrix not equal to 0 ஆ வந்தாலும் we can fix. From this let us say determinant of the matrix, rank of the matrix A is equal to 2. Do you agree? Yes. For our question, rank of the matrix A is equal to 2. Let us club A and B together. Let's see the possible solutions, right? So when I am clubbing A with B, 1 2 1, and it is going to be 2 4 2, and it is going to be 3 2 1. Okay, 1 to 1 2 4 2 3 to 1, right? So it is augmented with 2 3 2 such that it will become a non-square matrix now, and its order is going to be 3 cross 4. 3 rows 4 columns. Let's try and find the rank of this matrix. For that, let me rub this one. Guys, we all know what we all know. The thing is, when I am looking for the solution for this one, நமக்கு என்ன தெரியுமா? இது மேட்ரிக்ஸ் A. இது மட்டும் தனியா பார்த்தா மேட்ரிக்ஸ் A. இதோட டிட்டர்மினன்ட் எவ்வளவு? 0. அப்ப இதுக்கு நீங்க திரும்ப செக் பண்ணி பார்க்க வேண்டியது இல்ல. Take some other possibility. இந்த ரேங்க் இந்த மேட்ரிக்ஸோட டிட்டர்மினன்ட் ஆல்ரெடி 0 ஆயிருக்கு. நான் என்ன சொல்லிருந்தேன் அப்படினா, ஒரு நான் ஸ்கொயர் மேட்ரிக்ஸ்க்கு நீங்க வந்து ரேங்கை ஃபைண்ட் பண்ணோம் அப்படினா அதுக்குள்ள இருக்க மேக்ஸிமம் சப்ஸ்கொயர் மேட்ரிக்ஸை சூஸ் பண்ணி எத்தனை சப்ஸ்கொயர் வருதோ அந்த எல்லா சப்ஸ்கொயருக்கு வந்து டிட்டர்மினன்ட் ஃபைண்ட் பண்ணுங்க. இப்போ இதல பாத்தீங்கன்னா இது 3 cross 4 மேக்ஸிமம் 3 cross 3 வரைக்கும் நம்ம வந்து சப்ஸ்கொயர் மேட்ரிக்ஸை சூஸ் பண்ணலாம். அப்ப எல்லா பாசிபிள் 3 cross 3 மேட்ரிக்ஸ் இதுக்குள்ள இருந்து வெளிய எடுத்து எத்தனை பாசிபிலிட்டி இருக்கு? 1 2 3 இவங்க மூணு காலமை வச்சு we can form a 3 cross 3 matrix. Second column, third column, fourth column. With them we can pass one 3 cross 3 matrix. Third column, fourth column, first column. With them we can pass one 3 cross 3 matrix. Fourth column, first column, second column. We can pass one 3 cross 3 matrix. Like that, there are 4 possible combinations of 3 cross 3 matrix. With in the 4 combinations la ஏதாச்சும் ஒரு 3 cross 3 matrix ஓட determinant not equal to 0 ஆ வந்தாலும் rank of this non square matrix can be defined as minimum value of 3, 4. Clear? Yes. Let's proceed with this. So the correct answer in this case, அப்புறம் நம்ம என்ன பண்ணிக்கலாம், ஆல்ரெடி எனக்கு என்ன தெரியும் அப்படின்னா இந்த ஃபர்ஸ்ட் 3 காலம்ஸ் உள்ள டிட்டர்மினன்ட் 0 நம்ம இப்பதான் ஃபைண்ட் பண்ணோம். அது மேட்ரிக்ஸ் A தானே. அப்ப நான் என்ன சொல்றேன்னா செகண்ட் 3 காலம்ஸ் எடுத்துக்கலாம்னு சொல்றேன். யார் யாரு 2 4 2 1 2 1 2 3 2. Shall we proceed? Yes. Let's go ahead. Find out the determinant of this matrix. So this is AB and let us find out the determinant of this A augmented B. Should be equal to 2 into 4 minus 3 is 1 minus 1 into 8 minus 6 will give you 2 plus 2 into 4 minus 4 will be 0. What is the answer here? 2 minus 2 will become 0. So I understood the second conclusion is here also I am getting what? 0. Right? For these three combinations I am getting 0. Let us proceed further. Let us take some other possibility. Right? So because for the second possibility also I am getting 0. Am I correct? If I make any mistakes, please correct it by myself. Sorry, please correct it by yourself. 2 into that is 4 minus 3 will be 1. Minus 1 into if I remove this one 8. 8 minus 6 will be 2. If I remove these 2, it will become 4 minus 4 will be 0 only. So determinant of the second possibility also become 0. What about the third possibility? Let's see. Let's check. There is going to be 1 2 1. That is third column. Fourth column 2 3 2. First column 1 2 3. Let's try. And it's going to be 1 into 9 minus 4 become 5 minus 2 into 6 minus 2 will be 4 plus 1 into 4 minus 3 will become 1 such that what I am getting 5 minus 8 plus 1 will be not equal to 0 because 6 minus 8 will be minus 2 that is not equal to 0. What I have understood, I took all possible combinations of 3 cross 3 matrix. அதில் எனக்கு என்ன வந்திருக்குன்னா third possibilities determinant வந்து not equal to 0 வந்துருச்சு. So what is the conclusion? Rank of this non-square matrix is equal to rank of guys இதுக்கு இவ்வளோ பாசிபிலிட்டி போடணும் அப்படின்றத நீங்கள் இப்போ திங்க் பண்ணி பார்க்கலாம். இட் வில் பிகம் வெரி ஈஸி ரைட். எக்லான் ஃபார்ம் வந்து ரொம்ப ஈஸியாக இருக்கும். நீங்கள் டக்கு டக்கு டக்குன்னு ஆன்சர் பண்ணதெல்லாம் ரைட். எவ்வளோ நேரம் ஆகும் போது டிட்டர்மினன்ட் ஃபைண்ட் பண்ணாலும் அப்படியே மைண்டில் உங்களுக்கு ப்ராக்டிஸ் ஆகும் லேட்டர் ரைட். ஃபைன். What is the conclusion now? Anyway, given non-square matrix, I found it is what? It's determinant. ஏதாச்சும் ஒரு possibility of determinant not equal to 0 வந்தாலும் right, its rank of the matrix should be defined as minimum value of number of rows comma columns. இவங்க ரெண்டு பேர்ல மினிமம் எவ்வளவு இருக்கு? 3 is the minimum value, so it is equal to 3. Now what is the rank of A? Rank of A is 2. We found rank of AB 3. So what is the answer? Rank of A is not equal to rank of AB. நம்ம என்னங்க பார்த்தோம்? Rank matrix A வந்து singular matrix, whereas AB is not singular matrix. So if they are not equal, then what is the correct answer? If rank of A is not equal to rank of AB, so the correct answer in that case, the correct answer is no solution. For the given system, you will never have any solutions. You will never have any solution, right? So let us take one more example, right, in order to get the very clear idea regarding this one, right? So let me rub this one. Yeah, let us take some other example, right, such that you will get the very clear idea, right? Yes. Now what I am going to do, let us take x1 plus x2 plus x3 equal to 2. Now let me write x1 plus 2x2 plus x3 equal to 3. Now let us take twice of x1 plus twice of x2 plus twice of x3 equal to 4. Let's find out the determinant of this matrix, right? If you want to find out the determinant for rank solution for this system of linear equation, first let me write it in matrix form. It is going to be 1 1 1 and 1 2 1 and 2 2 2. Yes, it is 2 2 2 and its number of unknown variables are x1, x2, x3, whereas in the RHS we have matrix B. Matrix B is 2 3 4. Happily. What is the next target? Is it homogeneous system or non-homogeneous system? That is non-homogeneous system. Why? Because A is existing as well as B also existing, right? So what is your next task? Your next target is you have to find out whether this system is going to provide solution or no solution. For that, what you have to do? Find the rank of A and then find the rank of AB, right? So let us take matrix A. Matrix A what determinant find? Determinant of matrix A is equal to, let us see, 1 into 4 minus 2 will be 2 minus 1 into 2 minus 2 will be 0 plus 1 into 2 minus 4 will be minus 2, such that plus 2 minus 2 already it is 0. Plus 2 minus 2 will be give you 0. What is the conclusion? So given matrix A is singular matrix. First thing is matrix A is a singular matrix. Now let us proceed further. Matrix A is singular matrix. But what is the conclusion here? If your matrix A is singular, that is matrix A, determinant of matrix A is 0. So if matrix A is singular matrix, then its correspondent rank of the matrix can be defined as, we all know, it is less than 1 and the order is what? 1 to n, right? Now from this, what is the conclusion? Order of the matrix A is 3 only, so it has to be less than 3. Now this matrix have two possibilities. This value might be equal to 2 or this value might be equal to 1. In order to find out the current rank of this matrix, we have to find out the determinant of subsquare matrices. Since it is 3 cross matrix, 3 cross 3 matrix, its subsquare is 2 cross 2, right? இப்போ என்ன படிக்கலாம் 2 minus 1 not equal to 0. ஏதாச்சும் ஒரு 2 cross 2 matrix ஓட determinant not equal to 0 வந்தாலும் rank of the matrix can be directly defined as 2. So I found the rank of this matrix. Rank A is what? 2. Now we have to club A with B such that, let me club A and B. So A is 1 1 1 and B is 1 2 1 and C is 2 2 2, and when we are clubbing it with the matrix B, it is going to be 2 3 4 such that, let us see, that is AB. A is being augmented with B. We have been clubbed them together, right? Such that now it is become a non-square matrix. We all know in non-square matrix how many rows are there? 3. How many columns are there? 4. Now we have to find out the rank of this matrix, right? So let us see. In order to find out the rank of this matrix, let me rub this person, right? So let us rub them. After rubbing these things, now let's find what we have to do. Guys, listen. Since first 3 columns நம்ம choose பண்ணோம் அப்படினா அதோட determinant 0 தான். ஏனா அது matrix A. Matrix அப்ப நம்ம என்ன பண்ணிக்கலாம்? Select second 3 columns like 1 2 2 1 1 2 2 3 4. Its determinant is going to be, right? So let us find the determinant of this person. That should be equal to 1 into 4 minus 6 will give you minus 2, minus 1 into 8 minus 6 will give you plus 2, plus 2 into 2 minus 2, sorry, 4 minus 2 will be 2 only. Such that what I am getting, minus 2 will be minus 4, and here it is plus 4, it is also equal to 0. Let's take some other possibilities. Other possibilities in the sense, I took first 3 columns are 0 because that is matrix A. Second 3 columns also going to be 0. Let us take third possibility. Third column, fourth column, first column, right? So let us plug them together and find out the determinant of them also, right? So determinant of those matrices. Let us see. In order to find them, right, I have to select column number 3, column number 3 1 1 2, column number 4 2 3 4. Column number 1 will become 1 1 2. If you find the determinant for this one, let's see, 1 into 6 minus 4 will be 2, minus 2 into 2 minus 2 will be 0, plus 1 into 4 minus 6 will be minus 2, such that this is also equal to 0. So third possibility also will become 0. Let's take the last possibility, right? We can go with the fourth column, first column, second column, right? Fourth column is what? 2 3 4. First column is what? 1 1 2. Second column is 1 2 2. If you find the determinant for this one, right, let's see, 2 into 2 minus 4 will be minus 2, plus 1 into 6 minus 8 will give you minus 2, plus 1 into 6 minus 4 will give you plus 2. Let's see minus 4, right? So there is minus 4. Here I am getting plus 2. Guys, correct. Let me check it by myself. Values are correct. 2 3 4 and 1 1 2 1 2 2, right? So let's see, 2 into 2 minus 4 will give you minus 2, right? And then I have to put minus here, right? I forget to consider that one. So minus 1 into 6 minus 8 will give you minus 2 only, and then yes, that is 6 minus 4, that will be 2 only. That is correct, right? Anyway, 2 into minus 2 will become minus 4. Here minus into minus will become plus 2, plus 2 plus 2 will become 4. So plus minus 4 plus 4 will become anyway 0. See, all possible 3 cross 3 matrix are going to be equal to 0, right? So the conclusion is what? Let me rub this one. So the conclusion is, I took 4 possibility. All these 4 possibilities, 3 cross 3 determinant are going to be equal to 0, such that the rank of this matrix, rank of A augmented B, should be reduced to less than minimum value of, right, number of rows comma 4, right, 3 comma 4, and it has to be, at least it has to be greater than 1, such that the minimum value 3 comma 4 minimum value 3 da, right? So this rank of A augmented B can be further written as, it lies in between 1 and 3. I can consider 1 because it is less than or equal to 1, but here it is less than 3, restricted, we cannot touch 3 now. பட் அப்ப என்ன வரலாம் பாசிபிலிட்டி either it may be 1 or 2. அதுக்கு நாம என்ன பண்ணோம் all possible combination of 2 cross 2 subsquare matrix choose பண்ணோம் because initially I was going up with the maximum subsquare matrix that is 3 cross 3. Now we are going up with the next possibility that is 2 cross 2. இப்போ 2 cross 2 ஏதாச்சும் ஒரு காம்பினேஷன் எடுத்துக்கோங்க see that இத மட்டும் எடுத்தீங்கன்னா 2 minus 1 will become not equal to 0 because determinant of first 2 cross 2 matrix here itself I am getting not equal to 0. I said out of all possible combinations of 2 cross 2 matrix, right, determinant of any only one 2 cross 2 matrix is not equal to 0, then that system rank is going to be 2 only, right? So the conclusion is rank of A augmented B also will become equal to 2 only. Shall we write the answer now? Yes, because we found the rank of A as well as we also found the rank of B also, right? So let me write these things together. So let us solve all these things, right? Let me run all those things. Let us try and find the answer, right? So the conclusion is, since rank of A, one second, I don't want that marker because it's freezing. What we found, rank of A, rank of AB, right, both are equal to what? 2. Right? Since rank of A, rank of B equals such that that system will provide solution, right? Kandipa solution varum. But the question is whether it is unique solution or infinite number of solution. Adu theriyade. Now tell me what is the number of unknowns? 3. Why? Because we have 3 cross 3 matrix. 3 vector variables are there, x1, x2, x3. Right? 3 variables are there. So the conclusion is rank of A, rank of AB are equal, sir. I am really very happy. But the third condition is, since these two guys are equal to 2, whereas number of unknown is 3, such that it is less than number of unknown. Getting me? Number of unknown is 3, whereas rank of these people is only 2. So for this one, the corresponding solution is, given system will provide infinite number of solution. Given system will provide infinite number of solution. I hope things are very clear to you all. Right, so that system will provide infinite number of solution. Clear? That's all, right? So this is how we are finding solutions for various homogeneous and non-homogeneous systems. Okay, fine. Let me run these things. Let us start the next chapter. Yeah. Now we are going to look at the properties of dependent and independent systems. Right? Dependent and independent vectors. Or we can also write dependent and independent vectors. Dependent and independent vectors. Keep that in. Next we are going to discuss about dependency and independency. Sir, இப்போ ஒரு 2 set of vectors இருக்கு அப்படினா क्वेश्चन வந்து என்னன்னா அவங்க ரெண்டு பேரும் டிபெண்டன்ட்டா இருக்காங்களா இல்ல இன்டிபெண்டன்ட்டா இருக்காங்களா, ரைட்? So in order to find out the dependency and independency of the vectors, we should scale them, right? So let's see. For an example, I have a matrix like this, right? A 2 cross 2 matrix. Right, keep that in. We are talking about dependent and independent vectors, right? So linearly dependent and independent vectors, right? So for an example, the coefficient of vector 1 can be defined as 2 2, whereas coefficient of vector 2 can be defined as 4 4. Now I am just calling, see there, that is row 1, or I can say vector 1 set equation, right? Now I can call like this. See, this matrix can be, it is being defined like this. Let us consider x1, x2, and it is equal to 0. Now take this equation, let me write it. Actually in linear equation it can be written as 2 times of x1 plus 2 times of x2 equal to 0. Second equation can be written as 4 times of x1 plus 4 times of x2 equal to 0. Let me treat this one as equation number 1. Let me treat this one as equation number 2. Now tell me, is there a dependency between them? Yes. The dependency is equation number 1, if you are multiplying it by 2, you 2 ஆல multiply பண்ணீங்க அப்படினா that will give you the value of 4 times of x1 plus 2 times of x2, that is nothing but which is equal to what? Equal to 0, which is equal to equation number 2. Yes or no? Yes. So what is the conclusion here? So the conclusion is first row, right? So row number 1 நீங்க 2 ஆல மல்டிப்ளை பண்ணீங்க அப்படினா that will become equal to row 2, right? இந்த மாதிரி ஒரு row வந்து row or column, right? So if your row or column, right, is being expressed, right? So is being expressed with the help of scaling factor of another row. If one row is being expressed with the scaling factor of another row, or one set of vector equation is being expressed with the scaling factor of another set of vector equation, then that is called linearly dependent system. That system is called linearly dependent system, right? So the system is called linearly dependent system. The system is called a linearly dependent system. I hope things are clear to you all. Now what do you mean by linearly independent system? இப்போ நம்ம இன்னொரு விஷயம் பார்க்கலாமா? ஒரு linearly dependent system ஓட மேட்ரிக்ஸ் வந்து சிங்குலரா இருக்குமா இல்ல நான் சிங்குலர் மேட்ரிக்ஸா இருக்குமா நான் கேக்குறேன். ஓகே லீனியர் டிபெண்டன்ட் சிஸ்டம் அப்படின்னு நம்ம சொல்லிட்டோம். இதோட டிடர்மினன்ட் மெத்தட் டிடர்மினன்ட் ஃபைண்ட் பண்ணுங்களா. If you are finding the determinant 8 minus 8 will become 0. So what is the conclusion? Linearly dependent system in the sense that is singular matrix. Matrix is going to be what? Singular matrix. அப்ப நம்ம டைரக்ட்டா என்ன பண்ணிக்கலாம், ஒரு சிஸ்டம்ல ஒருவேளை வந்து நிறைய காம்பினேஷன்ஸ் கொடுத்துருக்கும்போது உங்களுக்கு தெரியல டைரக்ட்டா இந்த மாதிரி ரிலேஷன் ஃபைண்ட் பண்ண முடியல அப்படின்னா find the determinant of that system. அதை ஃபைண்ட் பண்ணிட்டீங்கனாலே உங்களுக்கு தெரிஞ்சிடும் whether the system is linearly dependent system or independent system. Clear? Yes. Right? So that system will provide what? That is singular matrix. Singular matrix in the sense determinant of the matrix will become equal to 0. Clear? Shall we proceed? Yes. Let me take one more example. Let me rub this one. Right? Simply understand, right? Simply understand. It's very easy. Mathematics is very easy. Yeah. Let's take some other example. Let me select 1, 2, 3, 4. Right? And again it is being defined as x1, x2. Let me consider some other variables. 1, 2, let us consider 3. Right? Now here take some other variable. Yeah. Now what I am going to do, check whether the given system is linearly dependent system or independent system. Anyway, I don't need to be panic about these things at all, right? So let me define like this, right? Directly you can consider this value as 0 otherwise. First, simply understand. Now tell me, the linear equation, if I write like this, it can be written as x1 plus twice of x2 equal to 0, right? And it is going to be 3 times of x1 plus 4 times of x2 equal to 0. Yes, let us take some homogeneous systems, right? You can also consider non-homogeneous. I'm just going with the homogeneous system, right? So x1 plus x2 equal to 0, 3x1 plus 4x2 equal to 0, right? Now the conclusion is what? Now tell me, if equation number 1, let me take this one as the equation number 1, this one as the equation number 2. Now tell me, in last case la panna mari, in the other scaling factor like 1, 3, 4, 5, 6 and the other variable use panni, direct row, I mean second equation, first equation வந்து உங்களால express பண்ண முடியுமா? Or otherwise first equation second equation வந்து கொண்டு வர முடியுமா? Is there any chances? No. So the conclusion is what? Since the equation number 1 and equation number 2 are independent of each other, right? So 1 and 2 are independent of each other. அது நீங்க பார்த்தோனே ரொம்ப சொல்லுங்க. Independent of each other. It means that is called what? Linearly independent system. That is called linearly independent system. Independent system, right? Last case நம்ம என்ன பார்த்தோம், that is linearly dependent system, because equations are depending on each other, but here there is no dependency. In case of linearly independent system, if we find the rank of the matrix, determinant of the matrix, see there 4 minus 6 is minus 2, but it is not equal to 0, so that is called what? Non-singular matrix. Your matrix is non-singular matrix. Expect theoretical questions. I am repeating, you will be tested for some worthless question, so make very clear notes. Clear? That is all about linearly dependent and linearly independent systems, right? So next we are going to discuss about few seconds. Next let us discuss about orthogonal vectors, orthogonal set of vectors, right? That will be convenient for us. Orthogonal set of vectors. Keep that in. Next we are going to discuss about orthogonal set of vectors. Orthogonal set of vectors, right? Now orthogonal set of vectors abina meaning enna? It's very simple. First of all, vectors in the sense I'm talking about x1, x2, x3 like that, right? So the conclusion is orthogonal set of vectors in the sense x1 transpose dot x2 will be equal to 0. That is called orthogonal set of vector. Or we can also you can define, right? You can also take x1, x2 transpose. You can take transpose for any one person, right? And then you can do the multiplication. Anyway, standardly take this one, right? Because all things will give you the same result only, right? So this is the condition, right, to obtain the orthogonal set of vector. Actually it means, first tell me what do you mean by orthogonal? Orthogonal in the sense selected vectors are going to be perpendicular to each other. It means in between x1 and x2, right, the phase angle difference, right, between them, the phase angle difference between them should be equal to 90 degree. That is called orthogonal set of vectors, right? Orthogonal set of vectors. x1 and x2 are equal to what? They are perpendicular to each other, right? Yes. So that is called orthogonal simply. Upon the number vectors answer it is equal to 0, right? So now let us take some example for that. Now let us consider x1 is being defined as, let me consider 1, and let us take 1, or otherwise let's take 2. Now let us consider x2, it can be defined as, right? So it is defined as minus 2 and minus 1. It is given like this. Now let me multiply them. First, before doing the multiplication at all, what is the order of this matrix? 1, 2, 2 rows are there, only one column, so 2 cross 2, sorry 2 cross 1. What about this one? That is also going to be 2 cross 1. Now the conclusion is, if you can you multiply these two matrices directly? Why are you taking transpose? You might think, sir, why are you taking transpose? Direct multiply. Direct multiply. Yeah? If you want to do matrix multiplication, right? Number of columns in the first matrix should be equal to number of rows in the second matrix. Now tell me, are they being equal? No. Either you have to take transpose for this one, or you can take transpose for this one, right? So let me take transpose for x1 such that x1 transpose in the sense rows are become columns, columns are become rows. If I take transpose, then it will become 1, 2, such that its order now it is become 1 row, 2 columns. Check this one. Number of columns in the first matrix, number of rows in the second matrix are being equal. Now I can do matrix multiplication, right? So x1 transpose dot x2 should be equal to x1 transpose in the sense that is 1, 2, whereas x2 is minus 2, minus 1. Shall we start? See there, first row with the first column, right? So that is 1 into minus 2, yes, minus 2, and then 2 into minus 1, that is 2 into minus 1, right? Such that what I am going to get, take plus 1 here, because we are looking for orthogonality, right? That is 1 into minus 2 will give you minus 2, 2 into plus 1 will give you plus 2, such that its value is going to be 0. Clear? So if we find any matrix like this equal to 0 on the chapter, that matrix is called what? Orthogonal set of vectors. Clear? That's all. I hope things are very clear to all. Our matrix and the orthogonal just to do the matrix multiplication, right? If you are just render matrix in multiplying, automatically you will get this result, right? Fine. So let us consider the next one. Next, this is called orthogonal set of vector. Now we are looking for orthonormal set of vector, right? So the next type is, next we are going to look at orthonormal set of vector, right? I said from each and every topic, right? So this beginning of each and every topic, there are numerous applications, right? If you have started looking the engineering mathematics in the application point of view, it may take more than 30 days for me in order to complete the maths, right? Application wise, but that is not in our syllabus and we cannot look at these things in that point of view. Understand this mathematics fully and then slowly in our futures, right? You will come to know its applications. Already we saw many applications in electrical subjects itself, right? Fine. Orthogonal also where we saw in signals and system. I hope you all remember. I have seen this, that is I had given these explanations for these orthogonal systems when I was talking about Fourier series. Do you remember? Just reverse your notes. Fine. Let us talk about the second person. I said that is called orthonormal vector. Orthonormal vector. So next we are going to orthonormal set of vectors. Orthonormal set of vectors will satisfy two conditions. The condition number 1 is, if you are taking once again x1 transpose dot x2 will be equal to 0. That is the condition number 1 for orthonormal set of vectors, right? Whereas if I will consider second vector, the second condition for orthonormal, right? If you are finding length of, right, first person, it should be equal to 1, that is magnitude, right? Similarly, length of x2 also should be equal to 1. That is called what? Orthonormal. It has to satisfy two conditions. If it is satisfies these two conditions, yes, then the system is what? Orthonormal. Let us consider some example for this, right? Let us take 1, 0, right? Don't write, because if I make any mistakes, I will correct it once again, right? x2, let me consider if it is 1, 0, let us consider 0, 1. Let's see what happened, right? First, let us find out the product, that is x1 transpose dot x2 should be equal to, x1 transpose can be written as 1, 0, x2 can be written as 0, 1, such that if I do multiplication, 1 into 0 will become 0, plus 0 into 1 will become 0, yes, condition number 1 is satisfied. So given set is what? Orthogonal vector as well as it is orthonormal இருக்குனா என்ன வரணும்? Condition number 1 மட்டும் தான் satisfy ஆகுது. Second condition, length of this vector. First we take this person. Guys listen. This x1 can be written as 1 0 அப்படினு எழுதிட்டீங்க இல்லையா? It means 1 into I you can write like this plus 0 into j. Similarly, x2 can be expressed as 0 into I plus 1 into j. Such that if you are finding magnitude for this function, x1 is going to be under root of magnitude coefficient of I, that is 1 square plus second person is 0 square, it is equal to 1. Second is x2 can be directly we can write from here, but your understanding I am writing like this 0 square plus 1 square under root, that is also equal to what? 1 only. Such that see there x1 equal to 1, x2 also magnitude of x1 as well as magnitude of x2 are equal to 1. So two conditions are satisfied. So the given set of vectors are what? Orthonormal set of vectors, right? Or sometimes you will also be tested. Identify the orthonormal set of vectors. Question எப்படி கேட்பாங்கன்னா இந்த மாதிரி நாலு set of vectors ஆப்ஷன்ல கொடுத்துருவாங்க. ஆப்ஷன் A, ஆப்ஷன் B, ஆப்ஷன் C, ஆப்ஷன் D. Question என்ன கேட்பாங்கன்னா ஐடென்டிஃபை தி ஆர்த்தோனார்மல் செட் ஆஃப் வெக்டர்ஸ் அப்படினு கேட்பாங்க, ரைட்? எதர் இப்போ நாலு காம்பினேஷன் கொடுத்துட்டு 1 2 3 4 நாலு ஆப்ஷன் கொடுத்துட்டு அது இந்த மாதிரி டூ செட் ஆஃப் வெக்டர்ஸ் வந்து கொடுத்துட்டு கீழ வந்து 1 and 2 are correct, 1 2 3 are correct, 1 2 3 4 are correct, only one correct, like that you might be expected the question from this area. So to remember, understand the process, that is enough, right? So that is called what? Orthonormal vector, right? So next we are going to look at that is next one, that is called normalized set of vectors, right? Normalized vectors, right? Let us see. Next one is normalized vectors, right? So let me rub this one. Let me explain about normalized vector, right? So let us see normalized vector, right? Normalized vector, right? Normalized vector. When we are looking for normalized vectors, right? Normalized vectors in the sense we should find out, right? That is first what we have been talking about orthogonal vectors and then orthonormal vector. Now we are looking for normalized vector. But normalized vector அப்படினு கேக்குறாங்க, that is very simple. We should find normalized vector. Let me define. What should we consider? x1 dash. Actually it should be equal to x1 upon magnitude of x1, right? Comma similarly second person x2 dash, that can be expressed as x2 upon magnitude of x2. What do I mean? That is called a normalized vector. Appadina meaning enna? It means, for example, a vector is being defined like this. It is given as 1 2. There is one more vector is given, right? Let us consider like 1 1, right? Now normalized vector கேட்டாங்க அப்படினா, right? Normalized vector in the sense we should find x1 dash. For that we have to find, see, take x1, first variable இங்க என்ன இருக்கு? 1 upon find out the magnitude of x1 அப்படினா whole x1 நீங்க கன்சிடர் பண்ணனும். whole x1 ஓட magnitude இங்க என்ன இருக்கு? 1 into I vector plus 2 into j vector தான் இருக்கு, கரெக்ட்டா? இதோட magnitude என்னங்க வரும்? root of 1 square plus 2 square, such that it will be equal to root 5. So இப்போ எப்படி எழுதலாம்? first person can be written as 1 upon root 5. Similarly x1 dash, another one variable will be there na, there will be one more variable, that is equal to what? 2 upon root 5. So the conclusion is what? And a variable divided by its whole orthonormal value, right? Whole magnitude divided by a answer enna varum. So it can be this in the expression orthonormal enna appadina. So the correct answer for this one, right? Orthonormal for this one, let me write whole expression. x1 dash can be written as 1 upon root 5, 2 upon root 5, that is the orthonormal. Similarly, can you write the answer directly for this one? x2 dash 1 upon, இதோட whole magnitude என்னங்க வரும்? root of 1 square plus 1 square, that is going to be 1 by root 2. Second person also 1 by root 2. Clear? That's all. That is how we are finding orthonormalized vectors. Clear? I hope things are very clear to you all. Clear? Yes. Take care of these things now, right? Make very clear notes, right? Yeah. Next keep that in. We are looking for next topic is eigenvectors and eigenvalues, right? Till now, right, we have been analyzing the properties of basic fundamental systems, right? Now I told you, right, நம்ம ஸ்டார்டிங்ல வந்து மேட்ரிக்ஸ் இன்ட்ரோடக்ஷன் கொடுக்கும்போது நான் சொன்னேன் இல்லையா, ஒரு ஸ்பேஸ்ல வந்து ஒரு ஆப்ஜெக்ட் எப்படி நின்னுட்டு இருக்கு அப்படின்னா அந்த ஆப்ஜெக்ட் வந்து இந்த பாயிண்ட்ல இருந்து இன்னொரு பாயிண்ட்க்கு நீங்க மூவ் பண்றீங்க அப்படின்னா that is called vectors, set of vectors, right? அந்த ஒரு பாயிண்ட்ல இருந்து இன்னொரு பாயிண்ட்க்கு மூவ் பண்ணும்போது என்ன ஆகும்? That is, it means we are changing the value. Are you getting me? எர்த் இங்கே இருக்கோ, சேட்டலைட் என்னோட ஃபிங்கர் டாப்பில் இருக்குன்னு வச்சுக்கோங்க, இப்படி இருக்கோ. இப்போ சேட்டலைட் வந்து இந்த பொசிஷன் வந்து நான் மூவ் பண்ணணும். அப்படின்னா மீனிங் என்ன? ஃபர்ஸ்ட் we are changing the direction as well as length of the satellite from the origin, right? It might follow actually வந்து சர்க்கிள் தான் ஃபாலோ பண்ணும், ரைட்? கிளியரா சொன்னோம் அப்படின்னா, பட் எக்ஸாக்ட் சர்க்கிள் it won't follow, right? If you see, it is looking like sometimes it is following ellipse கூட ஃபாலோ பண்ணும். Why? Because it depends on the gravity that we are facing, right? Gravitational force. So the conclusion is, if it is following an ellipse, for an example, if it is following an ellipse follow பண்ணது அப்படின்னா ஒவ்வொரு பாயிண்ட்லயும் ஒவ்வொரு டிஸ்டன்ஸ்ல இருக்கும், right? So distance, length is vary as well as its direction also keep on varying. So what is the conclusion here? அப்ப length வந்து vary ஆகுது அப்படின்னா that is called eigen value, and direction vary ஆகுது that is called eigen vector. It's over. There are no big things to understand, right? Same applications especially you can observe in your 3D games, right? நீங்க டாக்டர் டிரைவ்லாம் ப்ளே பண்றீங்க, NFS, right? அதெல்லாம் நீங்க கிளியரா அப்சர்வ் பண்ணி பாருங்க. ஜஸ்ட் நீங்க இமேஜின் பண்ணி பாத்தீங்கனாலே தெரியும் அதுல என்ன இருக்கும், நம்மளே அதுக்குள்ள போயிட்டு இருக்க மாதிரி இருக்கும். that visualization will happen, right? So that thing is what it means, நம்ம ஸ்பேஸ்ல பாக்குற ஒரு குவாண்டிட்டி 3D ல இருக்கு, அதே குவாண்டிட்டி நீங்க சிஸ்டம்ல பாக்கும்போது you are getting that same experience. There are nothing to understand, right? Yes, fine. Let's consider eigenvalues and the eigenvectors. Now what do I mean by eigenvalue, eigenvectors? Eigenvalue I said, right? So anyway, let us keep the heading, let us directly enter into the maths, right? Eigenvalues, let us talk about eigenvalues and the eigenvectors, right? So we are going to define eigenvalues and eigenvectors. Okay, let us see these two people one by one, right? Now when we are looking for eigenvalues and eigenvectors, first of all, eigenvalues are, that is eigenvalues in the sense, that is roots of the characteristic equation offered by the matrix, right? That is the roots of the characteristic equation offered by the matrix. So this eigenvalue can also be considered as, it is also called what? Proper value, right? I said, right? It is also called proper value, right? Some people are calling it as latent root, some people are calling it as latent root, some people are calling it as characteristic root, all are same, right? Some people are calling it as characteristic root. Actually it is pole, right? Eigenvalues is nothing but poles of the system only, right? And eigenvectors in the sense, நீங்க ஒவ்வொரு டைமும் வந்து பொசிஷன் லென்த் வந்து இன்க்ரீஸ் பண்ணி டைரக்ஷனை மாத்துறீங்க அப்படினா followed by eigenvectors also will change. That is what I had been told you. I took some example also, right? I took some 2x2 matrix and I said initially suppose I have 1 1 some 2 3 value, with the value இங்க வந்து ஒரு 2 3 அப்படி இருக்கு அப்படினா what will happen? Its result value, இப்போ உங்களுக்கு ரிசல்ட்ல என்ன வேல்யூ கிடைக்கும்? See, you have to do multiplication. 1 into 2 plus 1 into 3 will give you 5. 2 into 2 plus 3 into 3 will give you 13, right? So that is 513. Initially வந்து இதோட பொசிஷன் வந்து 5,13 ல இருக்குன்னு வெச்சுக்கலாம், right? Now if you are changing the vector value 1 1 2 3, actually indirectly changing the vector value in the sense we are changing the eigenvalue. That is what I mean, right? Eigenvalues change பண்ணும்போது automatically eigenvector will change. You will see, right? Explain everything I will explain. For next value, for example, if I take 1 1, right? I am changing the vector by changing the eigenvalue. Now suddenly what will happen? 1 1 1 1 it will give you 2, right? 2 plus 3 it will give you 5. See there, initially I was sitting in the position of 5,13. Now my axis has been changed to 2,5. So the conclusion is what? We can change them by changing. That is called eigenvalue and eigenvector, right? I told you, right? Let's start our journey with the matrix. Let me define this thing. See there, A x b. That's all. This is Ax equal to b, right? Fine. We are defining these things in terms of matrix, right? Let us see how I am going to find the eigenvalues and eigenvectors, right? In order to find out the eigenvalues, first we should talk about the system, right? And then you can find out, that is with the help of input. Guys, listen. Ax equal to b is the non-homogeneous system. We all know. I am taking a certain system. That system is being under my control with the help of a signal. Now under this condition, right, actually for this system you will have certain characteristics and that character will provide some certain roots, that is called characteristic roots offered by the matrix or the system. And then that system is being derived by some other type of input signal, that is called your matrix B. Practically I am talking, okay, fine. So that is called matrix B. Now in order to find out the characteristics roots of this system, you will have to take your system matrix, find the characteristics roots of the system matrix, and then derive the system with the help of signal B. அடுத்து நம்ம என்ன பண்ணோம் அப்படினா first நீங்க characteristics roots find பண்றீங்க, and then I am merging the characteristics roots with the, what I can say vectors, such that we are going to obtain the matrix B, and we are going to see the changes in the system, right? Let us see all those things one by one, right? Sir, you go homogeneous. What? I don't know, some of you talking about some things, but I am not getting you what you are trying to conclude, right? Please ask me in the group, right, or in the WhatsApp, there is no problem. Then I will conclude, okay? Fine. Let's talk about eigenvalues and eigenvectors, right? Now, proper value data group or characteristic groups. If I select from now, right, let me take some example for that, right? For an example, first let us take 2 cross 2 matrix and we will see how to find out the eigenvalues and the eigenvectors for them. And then I will select 3 cross 3 matrix, right? We will do the same thing, right? Guys, some of you are raising the question. I am not getting you clearly. Please post your doubt in the group, right, or in the WhatsApp. I will reply, right? Fine. Let's see. Let us take some 2 cross 2 matrix. Let me demonstrate how to find out the eigenvalue for that, right? For an example, a matrix A is given us, right? A matrix A is given us. Let me consider 2, 3, 4. Let us consider some value, right? 4. Let us consider like this. And its correspondent eigenvector, we are going to consider x1, x2. Its correspondent eigenvector is x1, x2, right? Now, you can also select some other values for matrix B, right? So let us select 2, 3, right? Let me take like this. Anyway, what is our target? We have to select matrix A, right? Select matrix A. Matrix A, find out the, what I can say, characteristic equation in order to find out the characteristic roots, right? First we have to find out the characteristic equation. Step number 1, we have to find out the characteristic equation in order to find out the characteristic root, right? Anyway, if you want to find out the characteristic equation for the system, the standard procedure to obtain the value of characteristic equation is, right, first second order equation we will have some 2 set of procedure. We can directly go with what I can say procedure. Listen guys, directly we can go in the sense second order system order of the matrix is 2 cross 2. Its characteristic equation can be written as lambda square plus a times of lambda plus b, right, equal to 0, right? This is not matrix actually, take some other value, otherwise you will be confused. Okay, equal to 0. That is one way of obtaining the characteristic equation, right? Or you can also go up with the direct procedure is mod of, you have to consider matrix A minus lambda into I equal to 0. That is the second method. Either you can go up with the direct equation. In the method you follow panninga, finally you get this equation, until you can proceed further, right? Fine. That's up to you. Direct and equation is let me proceed in both ways in order to get the clear idea. So here in this case, A denotes the sum of eigenvalue. A denotes the sum of eigenvalue. A denotes the sum of eigenvalue, whereas B denotes the determinant of matrix. B denotes the determinant of matrix. B denotes the determinant of the matrix. Okay, let's proceed with this method. Sum of eigenvalue. Guys listen, I made a mistake here. That is not eigenvalue. Sum of principal diagonal. Sorry, my mind is thinking some other thing, I think, right? Yes. Principal diagonal. Principal diagonal are diagonal elements. This one, these two. Sum of principal diagonal. 2 plus 4. Add 6. Determinant of the matrix. Determinant in the sense product of diagonal 8 minus product of half diagonal 12. 8 minus 12 will give you minus 4. 8 minus 12. Okay. Such that if I substitute these two values here, then the characteristic equation of the system is going to be lambda square, right, plus 6 times of lambda s minus 4 equal to 0. Is there a mistake? No. Let us check whether we are getting the same equation in the method number 2 or not. See, in the method number 2, first write the expression for a minus lambda I. How will you write? Let me do it. For that one, right, first I have to write the matrix A. Matrix A is what? 2, 3, 4, 4 minus lambda. See, if it is the 2 cross 2 matrix, then we have to write 2 cross 2 unit matrix. I denotes unit matrix or identity matrix. 2 cross 2 matrix, 1, 0, 0, 1. That is the identity matrix. Only you have diagonal values, right? Let's proceed. If you reduce prime now, you are going to get. If I reduce this function, I am going to get 2 minus lambda into 1, such that I am getting 2 minus lambda. 3 minus 0, lambda into 0, such that I am getting 3. 4 minus lambda into 0, I am getting only 4. 4 minus lambda into 1, I am getting 4 minus lambda. Clear? After finding this one, I said find out the determinant, right? If you find the determinant for this one, it is going to be 2 minus lambda into 4 minus lambda, that is product of diagonal minus product of half diagonal. That is this function you are going to get 8 minus 4 lambda minus 2 lambda, you are going to get minus 6 lambda, you are going to get plus lambda square minus 12. Let me reduce this one. Lambda square minus 6 lambda minus 4 equal to 0. Is there any difference? Lambda square, right? Why I am getting minus 6 lambda here? Did I make any mistake? 1 second. Minus 4 lambda. Oh guys, listen. Here I put plus. Sorry. Here in the characteristic equation, lambda square minus a lambda plus b. I have not noticed. Sorry, please correct it. Okay, fine. Now you can compare. That's all. See that in both cases we are getting same result. So either you can follow this one or you can follow this procedure. Okay, it's up to you to get the correct answer, right? You will come to know correct answer, right? But the thing is what? This is the general procedure that we had. You can apply this procedure for all type of matrix like 3 cross 3, 4 cross 4, 5 cross 5, 6 cross 6. This is the generalist procedure, common procedure for all, right? Whereas this procedure is only applicable for 2 cross 2 matrix. Now, when we are looking for 3 cross 3 matrix, we have to go with some other set of procedures. Anyway, after finding the characteristic equation, what is your next target? We have to find out the value of eigenvalue, right? So let us see step number 2. Step number 1, we have to find out the characteristic equation. Yes, I found the characteristic equation. Step number 2, we have to find out the eigenvalue from the characteristic equation. How many eigenvalues are possible? Eigenvalue of the system should be equal to order of the matrix, right? What is the order of the matrix? 2 cross 2. So how many eigenvalues are possible? 2 eigenvalues, lambda 1, lambda 2, right? So we are using eigenvalues can be defined as lambda 1, lambda 2. So let me rub this one now. Let's see, we are getting what? Lambda square minus 6 lambda minus 4, right? That is what I got. After finding the characteristic equation, let's see. So the next task, I got lambda square minus 6 lambda minus 4 equal to 0. Use the quadratic equation formula to find out the roots for this one, right? In order to obtain the value of lambda 1 comma lambda 2, I am just going with the formula minus b plus or minus root of b square minus 4ac upon twice of a. So the answer is going to be what? Minus b value is minus 6 plus or minus under root of b square, that is minus 6 whole square, will give you 36 minus 4. Value of a is 1 and the value of c is minus 4. In the denominator, we are going to get twice of a is 1 only. So the answer is what? Let me reduce this one. Minus of minus will become plus 6 plus or minus 36. Minus into minus will become plus. So 4 into 4 will become 16. 36 means it will become 52. So we are going to get root of 52, right? Divided by 2. Right? Now by using calculus you can find, okay, if you are expecting the answer from my side, I will do it. That's not a problem for me. Yeah, just let's take root for 52. I am getting 7.211. So 6 plus or minus 7.211 upon 2. So the correct answer, if you reduce this one, it is going to be plus 6 divided by 2. I am getting one value is 4.4, right? Another value 6 minus 7.211. Yes, divided by 2. I am getting minus 0.055, right? So I got two values for lambda 1 comma lambda 2. They are equal to what? You can consider. Let me write like this. Lambda 1 is equal to what we got? 4.4, and for lambda 2 I got the answer as minus 0.605. Now after finding the value of lambda 1 and lambda 2, you can further proceed in order to find out the value of eigenvectors. Step number 3, we have to find out the value of eigenvectors, right? So let me proceed further in order to find out the eigenvectors. Let me rub these values now. I'm in need of eigenvalues only. So I'm rubbing rest of all people, right? Let's go ahead. Let's proceed further to find out the answer, right? Now the thing is, yeah. Guys, listen. The thing is, when we are going up with the eigenvalues at all, right? The thing is what? Now, after finding the eigenvalue, we are requested to proceed further with what? Homogeneous system. The thing is, usually I can consider one thing. While finding eigenvalues and eigenvectors, right? Our target is we are analyzing the system only. Eigenvalues and eigenvectors. Actually, we are analyzing the properties of the system. So, we no need to be bothered about the input signal that we are giving, right? sorry, at which type of signal that we are giving, right? So adha pathi neenga enna pandra direct inga both worry panna avashyam kadiyadu, right? So while calculating the eigen values, right, because I am just understanding the property of the system, right? I am just understanding the property of the system. I am repeating again, right? So appo enna panna appadina understanding system property in the sense, right, most of the times that value will be given as 0 only, right? Because they won't talk about this value, right? If it is 0 in the sense, we are talking about what? Homogeneous system. Anyway, you don't need to be panic about this one. Our target is what? We have to analyze the property of system, right? So system is our target, right? Anyway, now let us let's moving on to the step number 3. Understand the matrix. We don't need to follow the procedure that is given in the book, but in the procedure what we are trying to do, understanding those things is very important, right? Fine. Okay, we are understanding the property of system. I have a system, I would like to rotate that system from one point to another point. So what I have to do? Appo system oda property na enna pannum? I have to increase the velocity of the system, or acceleration, pressure, something I have to do, or its rotating direction, speed, right? You can consider any one person and you can change their personal characteristics, right? Fine. Let's see. Now if you want to obtain the value of eigen vectors, right? Let's take the system. I said if you want to obtain the value of eigen vectors, the procedure is once again, actually it means இதோட மீனிங் என்ன அப்படின்னா eigen values நீங்க ஃபைண்ட் பண்ணிட்டீங்களா? இப்போ இந்த eigen values வச்சு நாம என்ன பண்ண போறோம் அப்படினா we are going to find out the value of eigen vectors, right? Eigen vectors in the sense for each and every eigen value will provide its correspondent matrix. அப்படினா மீனிங் என்ன? நான் என்ன சொல்லிருந்தேன் இல்லையா, ஒவ்வொரு eigen value we are going to get different set of vectors in the sense the satellite is being fixed in the different position, right? So the conclusion is this individual eigen vectors will going to provide two set of different, what I can say, eigen values will going to provide two set of eigen vectors. So the next task is we have to find out the eigen vector for this system, right? In order to find out the eigen vectors, actually the target is we can go like this, that is A, right? Once again consider the matrix A, right? A into I am multiplying it by vector x and it should be equal to what? Each and every eigen value will provide correspondent matrix, right? So both are equal. I mean என்ன சொல்றோம் அப்படினா with the help of this individual eigen value we are going to obtain this new set of eigen vectors. Clear? Right. அப்படினா மீனிங் என்ன அப்படினா that this system A property will be shifted so another value with the help of lambda or eigen value. So each and every individual eigen value will provide individual eigen characteristics equations or systems, right? So is there any point that I am discussing about matrix B? If it is given, you don't need to be panic. It means that system is going to be tested by some signal. But what is your target? We are understanding the property of system, right? That's why I told you at any point you don't need to consider the matrix B, right? Let's proceed further. With this I can write further. We can, the thing is Ax minus lambda x, just to bring this lambda, right, to the left hand side such that Ax minus lambda x is going to be equal to 0. From this you can take x outside. A minus lambda, guys listen, lambda is an eigen value. ஒரு eigen value டைரக்ட்டா நம்ம மேட்ரிக்ஸ்ல இருந்து சப்ட்ராக்ட் பண்ண முடியாது. For that this lambda is being multiplied by a unit matrix and then you can consider the eigen vector equal to 0 such that this is going to be, right, the equation that we are using in order to obtain the eigen vector. Okay, so what is the conclusion? Step number 1, find the characteristic equation for the given system, right? Step number 2, from the characteristic equation obtain the eigen value, right? Step number 3, find the value of eigen vectors for individual eigen values, right? From this eigen value our next target is we have to obtain the value of eigen vectors. Clear? That's all. That's very important. That is what we are doing in this system. Okay, now anyway we are in the third step. Yes, in this third step our next target is we have to obtain the value of what I can say eigen vector. Very simple, right? For not to obtain the value of eigen vectors there are no big things to do, right? Let me rub these things. Yeah, so next target is okay 4.4 minus 0.605. Yes, remember, select the first eigen value. Let us consider 4.4. Its corresponding eigen vector. Very simple, very simple. The formula is what? A minus lambda into I x equal to 0. Now let us write. A what value? 2, 3, 4, 4. That is my matrix. Minus lambda is what? Selected value is 4.4. Exactly. Unit matrix. Matrix is 2 cross 2. So we have to consider 2 cross 2 matrix here. Equal to 0. Clear? If I reduce this one, right? Once again, sorry, 1 minute. Yeah, we have to consider vector also now. That is going to be x1, x2. Now it is become equal to 0. Now we shall proceed further. Write the equation for this. It is going to be 2. If I suppress this expression, either what you reduce what you are going to get, the thing is 2 minus 4.4, right? Minus 4.4 into 1 will become 4.4. 4.4 into 1 will become 4.4. These two people are 0 only. 0 into 4.4, 0 only, right? So 2 minus 4.4 will give you minus 2.4. Yes, minus 2.4. Second up, 3 minus 0 will give you 3 only. Yes. Third one, 4 minus 0 will become 4 only. Fourth one, 4 minus 4.4 will give you minus 0.4. Such that it will be multiplied by, right? So we can consider the vector x1, x2 and then you can just equal it to 0. Finally, we are going to get the vector equation, right? So from this, let me write these two values. Sorry, let me write this one. Let me write the vector equations further, right? So let us write the vector equation such that its vector equation is going to be minus 2.4 times of x1 plus 3 times of x2 equal to 0 exactly, and then 4 times of x1 minus 0.4 times of x2 equal to 0. Since we are talking about what? Properties of the system, right? Eigenvalue and eigenvector of the selected satellite, or you can select any object, 3D object, right? Okay. Let us reduce. If you say one equation reduce, let me go ahead with the equation number 2. When the equation reduce, I am getting 4 times of x1, right? Should be equal to, right? It is going to be 0.4 times of x2. Clear? Yes. Now, if solve it can be further written as x1 by x2, right? X1 by x2 can be written as 0.4 by 4. Or I can write, 10 multiple, it will become 4 by 40. Or I can write 1 upon 10. Such that we can write the relation is x1, x2, right? In vector, it can be written as, right? It can be written as what? x1 equal to 1 and x2 equal to 10. That ratio is what? x1 by x2 is equal to 1 by 10. Guys, listen. Actually, I will have to consider two type of vectors here. That is k1 and k2. This is correct k1 10 times of k2. That is the correct relation. Why? Because the thing is, actually in relation x1 equal to, if the x2 on the pass we are getting what? 1 by 10 into x2. Correct? That is x2 by 10. Do you know the value of x1 x2 exactly? No. But we got the relation only. x1 to x2 relation x1 equal to 1 by 10 times of x2. That is the relation that we are getting. But the exact value of x1 and x2 are not known, right? In order to write the exact value, we are multiplying it by a scaling factor. But anyway, usually we are considering the scaling factor value as 1. You can also consider k1, k2, some other, because that system will going to provide infinite values. You vectors value provide but the relation is what? x1 is equal to 1 by 10 times of x2. That relation only we are getting here. You can also use this expression to obtain the relation like this. Okay, fine. Let us consider. But this, what is the conclusion here? The conclusion is that is how we are getting vector equation, right? Vector, right? So relation between the vectors from the eigenvalue. Can you please do one thing? Take the second value, that is minus 0.605. Do the same process to obtain the vectors for that one, right? So the conclusion is what? So this is one set of vector, right? And we are going to get another set of vector, right? So we are going to get another set of vector for the second one, right? Okay. Let me rub this one. Let us take one more example for this, right? I am just giving the task to you all. Second, again lambda 2 equal to 0.605, right? Okay. Now let me take few more examples, right? Don't worry, slowly I will take many examples, then you will get the clear idea, right? There are no big things to understand, right? Once again, I came out. I hope all of you guys are watching. Yeah. It's going good. Fine. Let's go ahead. Next, what we are going to do? The thing is, let us take the second example. Let me consider example 2. Okay. Now, let us take some other type of matrix. Right? What I can do, let me write 3, 3, let us consider 0, right? Let us consider 1 and its corresponding value, let me consider x1, x2. Anyway, our target is what? matrix only, that is matrix A, right? So we are going to consider the input signal. If you want to see, given it is input signal, what is our target? We are analyzing the property of satellite. I am analyzing the property of that person. Since that person is not going to be tested by any signal, right? Fine. What is the conclusion here? Select the matrix A, proceed further. If you want to, right, matrix A would order in 2 cross 2 matrix. For a 2 cross 2 matrix, directly we can obtain the characteristic equation with the help of the standard procedure. What is lambda square minus A times of lambda plus B equal to 0. You can go with this one or second procedure, right? Anyway, in this procedure, lambda square minus A is what? A is sum of diagonal, principal diagonal. 3 plus 3, that is going to be 6 lambda. Whereas B is determinant of the matrix. Determinant in the sense 3 cross 3 will become 9, which is equal to 0. Yes. Can you break the roots directly? I am just asking you, right? Yes, I hope I can break this root. How? See there, product will be 9, addition will be minus 6, such that I can put minus 3, minus 3. Are you getting me? So the roots of lambda minus 3 into lambda minus 3 equal to 0. We can write like this. Exactly. Why not? So the conclusion is what? Lambda minus 3 into lambda minus 3 equal to 0. From this we can write lambda equal to 3, right? Lambda 1 and lambda 2 also equal to 3. That is called repeated eigenvalues. Right? Anyway, we got repeated eigenvalues. So what? That is we can happily move this. Right? We got 2 repeated eigenvalues. For this eigenvalue, again we have to find out the eigenvector, right? So when we are finding vector for this, anyway, first step we have to find out the characteristic equation. Yes. Second step we have to find out the eigenvalue. Third step we have to find out the eigenvector. Example, either you might be tested with this eigenvalue or you might be tested for eigenvector, right? Any one only, because time consumption is the matter, na? And 2 cross 2 matrix la full ah 3 cross 3 matrix la always eigenvalue கொடுத்துருவாங்க, eigenvector கேட்பாங்க. Otherwise eigenvector will be given, eigenvalue you will be tested for eigenvalue, right? Fine. Let's proceed. Next, let us take one more example. Sorry, eigenvalue, right? So lambda 1 equal to 3. Eigenvector find பண்ணலாமா? என்ன procedure? That is A minus lambda into I into x equal to 0. Yes, exactly. Let us write. Matrix A is 3 0 1 3 minus lambda we are going to consider 3, unit matrix 1 0 0 1. Its corresponding vector are going to be x1 x2 equal to 0. Clear? Now from this I can say that is going to be 3, right? So 3 minus 3 into 1. So 3 minus 3 will become 0. Let me write the matrix 0. Next 0 minus 0 will become 0. Next 1 minus 3 into 0 will become 1. Next 3 minus 3 into 3, sorry, 3 into 1 will become 3 minus 3 also going to be equal to 0. So what is the conclusion here? Its corresponding value. So let me consider x1 x2, right, equal to 0. Let us write the equation for this. It can be written as 0 into x1 plus 0 into x2 equal to 0. Yes. And this one can be written as 1 into x1 plus 0 into x2 equal to 0. Clear? Yes. So the conclusion is what? Here I can say, see, the value of x2 is not known. x2 value namakku theriyadhu, but x2 into 0 will become 0 only, na? So from this I can say x1 equal to 0. x1 equal to 0 vachikittu x2 ungalaala find panna mudiyuma? You cannot. Why? சரி, எங்க போய் சப்ஸ்டிட் பண்ணுவீங்க? இப்போ இந்த x1 க்கு நான் 0 நீங்க சப்ஸ்டிட் பண்றேன். சரி, இங்க தான் 0 into x1 அதுவும் 0 ஆயிடுவே. ஆனா இங்க 0 இருக்குல்ல, x ஓட வேல்யூ உங்களுக்கு தெரியாது. ரைட்? x ஓட வேல்யூ தெரியாது. நீங்க எங்க போய் செக் பண்ண முடியும்? 0 into x2 இது கம்ப்ளீட்டா 0 ஆயிடுச்சு. x ஓட வேல்யூ தெரியல. இதுலயும் இது கம்ப்ளீட்டா 0 ஆயிடுச்சு. Only x1 I can find, but x2 I cannot find. So x2 can be anything. So let me define it by k, variable k. So the vector, right, set of vector x1 x2 can be defined as, right, it can be defined as, right, இந்த மாதிரி ஈக்குவேஷன் வரும்போது என்ன எழுதலாம்? We can write that is 0, it can be k. Now the possibilities, இப்போ இந்த k ஓட வேல்யூ என்னவா இருக்கலாம்? கவனிங்க, this k might be 0 or this k might be 1 or this k might be 2 or this k might be 3, etc. இப்போ இந்த மாதிரி different values வரும்போது the conclusion is, suppose if the value of k equal to 0, if it is equal to 0 வருது அப்படினா you are getting what? 0 0. It means x1 and x2 both are 0. they are linearly depending on each other because both are not equal to 0, right? So the conclusion is what? If I put some 1, 2, 3, some other values putting up, they are what? Linearly independent, right? So what is the conclusion? If I put k equal to 0, then they are become linearly dependent. If I am putting k equal to some other value 1, 2, 3, 4, 5, 6, they have become linearly independent. So what is the conclusion here? Whenever we have repeated roots, இப்போ நமக்கு ரெண்டு வேல்யூ வந்தது ரெண்டுமே 3,3 தான். Repeated roots வரும்போது the resultant eigen vectors, right, the set of the linear vectors, linear eigen vectors are going to be, right, so the resultant set of eigen vectors may be linearly, right, so there are two possibilities. They may be linearly independent or they might be linearly dependent, right? So they might be linearly independent or they might be linearly independent. Two cases could be possible. It is depending on the value that we are choosing. Getting me, right? Make this statement clearly, that is very important because we will be tested for some worthless 1 mark questions. I told you already, right? So what is the conclusion? Whenever we are coming up with the right repeated eigen values, its resultant eigen vector, right, eigen set of vectors, right, so eigen vectors may be linearly dependent or independent each other, right? Actually we have to find out two set of vectors separate, right? அப்ப நம்ம என்ன சொல்றது, first lambda 1 equal to 3 அப்படினு போட்டு ஒரு வேல்யூ வருதா, திரும்பவும் lambda equal to 3 ன்னு போட்டீங்கன்னா இன்னொரு செட் ஆஃப் வெக்டர் வரும், ரைட்? அந்த ரெண்டு வெக்டரையும் நம்ம கன்சிடர் பண்ணனும், ரைட்? சோ அப்படி கன்சிடர் பண்ணும்போது ரெண்டுமே ஒரே வேல்யூ தான வரும். இங்க 0 கேனா அதுக்கும் 0 கேனா நீங்க டிஃபைன் பண்ணுவீங்க. But the thing is that value of k is not known. K ஓட வேல்யூ தெரியல அப்படிங்கறப்ப I cannot directly define. If it is 0 then they are linearly dependent. If it is equal to 1 then there is different values, then they are linearly independent. So without knowing the value of k I cannot directly guess them. So let me define. So the conclusion is depending on the value of k, that system might be that linear set of vectors might be what? Dependent or independent each other. That is the answer for this one. Okay, fine. So let us continue, right? So just to do remember, repeated eigenvalues வரும்போது அதோட corresponding eigenvectors might be linearly dependent or independent. Just to do remember that statement, right? Because we will be tested for some worthless 1 mark questions theoretically. Like that you can go ahead, right, with many examples, right? We can find many examples. Yes, let me take some other values. Yes, okay, let us take 0 here, 2. Okay, let me take x1, x2. Let's proceed further. Fine. What is the next thing? So we are going to consider once again the next task is we have to consider matrix A, right? Matrix A ola neenga enna pannum, once again write the equation, characteristic equation, lambda square minus sum of eigenvalue, that is 4 plus 3, that is going to be 7, right? So there is 7 times of lambda, that is going to be 7 times of lambda. And what about its products? Its product is going to be 4 into 3 will become what? 12 equal to 0, right? Can you break them directly? Wait a minute. If I will break this one, let me consider minus 4 minus 3. Yes, I got the answer. So it is going to be what? 12. Such that it is going to be what? We can write lambda minus 4, lambda minus 3 equal to 0. 4 minus 3 equal to minus 7. Minus 4 into minus 3 will become plus 12 only, right? So that is correct. So we got two eigenvalues, lambda 1 equal to 4 as well as lambda 2 equal to 3. So the first step, right? We know how to obtain the eigenvalue. Now that is first step, find out the characteristic equation. Second step, find out the characteristic roots or eigenvalues. Step number 3, we have to find out the value of eigenvectors. Let us keep our attention with the eigenvectors. If you want to know the value of eigenvector, right, let us consider lambda 1 equal to 4, right? Lambda 1 equal to 4, what will you do? First write the equation. Shall I write the answer directly? Actually the formula is we know a minus lambda into I அப்படினு நம்ம எழுதுவோம், கரெக்ட்டா? ரைட்? சோ அப்ப a ஓட வேல்யூ எவ்வளவு? 4203. एक्चुअली என்ன வரும் அப்படினா யூனிட் மேட்ரிக்ஸ்ல டயகனல்ல மட்டும் தான் வேல்யூ வரும். That things we know. அப்ப அந்த டயகனல்ல இருக்க வேல்யூ நம்ம லாம்டாவால மல்டிப்ளை பண்ணா இதுவும் என்ன வந்துரும்? லாம்டான்னு வந்துரும். லாம்டாவோட வேல்யூ நீங்க 4 னு சப்ஸ்டிட்யூட் பண்ணீங்கன்னா this is become what? That is equal to the value of lambda I, 4. அப்ப டைரக்ட்டா நீங்க மைண்ட்ல ஃபிக்ஸ் பண்ணிக்கலாம். டயகனல்ல இருக்க வேல்யூ மட்டும் மேட்ரிக்ஸோட a ஓட ப்ராப்பர்ட்டி சேஞ்ச் பண்ணும். இப்போ இங்க 4 இருக்கா, டைரக்டா இந்த 4 வந்து நீங்க கன்சிடர் பண்ண போற ஈகன் வேல்யூவால சப்ட்ராக்ட் பண்ணிக்கலாம் டயகனல் இருக்க வேல்யூ. அதே மாதிரி இங்க 3 இருக்கா அதே ஈகன் வேல்யூவால சப்ட்ராக்ட் பண்ணா you are getting a minus lambda. Directly we can consider. So lambda 4 அப்படினா now let me write the answer. 4 minus 4 will be 0. Yes, and here it is 2 only, here it is 0 only. 3 minus 4 will be minus 1. That's all. That is what you are going to get. Right? So the conclusion is, but anyway, you can go ahead with the procedure if you want. Shall we write the answer? Yes, let us write. So from this, first equation becomes 0 into x1 plus second equation is 2 into x2 equal to 0. Similarly, second expression 0 into x1 minus 1 into x2 equal to 0. Such that what shall we do now? 0 into x1 0 only. So the conclusion is what? x2 equal to 0. Because similarly நீங்க ரெண்டு ஈக்குவேஷன்ல எதை சால்வ் பண்ணாலும் அதே ஆன்சர் தான் வரும். இப்போ இங்க பாருங்க 0 into x1 0. So 2 into x2 equal to 0. x2 equal to 0 only. x2 equal to 0. Can you guess the value of x1? No. x1 might be what? Infinite variable. That value is not known, right? Now let us proceed. So x2 equal to 0, x1 equal to k, right? So take this second what I can say. Okay, first let us write the answer somewhere here. We got the linear vectors, right? That is x1 x2, right? So that is x1 x2, and here we are going to get possibilities are that is going to be 0. Here I got x1 will be k vandirukka. Yes, that is k. Slowly be patient, understand these things. That is when lambda equal to 4. Next case lambda equal to, second we got lambda equal to 3 now. Repeat the same procedure. Obtain the eigen vectors for second eigen value, right? So the second eigen value is what? Second eigen value is 3, right? Do it by yourself. Let me write the answer here itself. I told you அப்ப என்ன வரும்? eigen value-வால diagonal matrix மட்டும் செப்பரேட் பண்ணனும், right? Diagonal values மட்டும் செப்பரேட் பண்ணனும். 4 eigen value is 3. 4 minus 3 will be 1. 2 only. Sorry, 2 only. 0 0 only. Because diagonal value only will change. 3 minus 3 will going to be equal to 0. Such that I can write this one is x1 x2, right, equal to 0. If I write the answer for this one, it can be written as 1 into x1 plus 2 into x2 equal to 0. From the first equation we can do something, but in the second equation we cannot do something, sorry, anything. 0 into x1 plus 0 into x2 will become equal to 0. Can you find anything from this equation? No. Since 0 into x1, 0 into x2 in the sense, without knowing x1 or x2 value வந்து உங்களால எப்படி ஃபைண்ட் பண்ண முடியும்? 0 into x2 will become 0. 0 into x1 also will become 0. Such that this whole equation will become 0. I cannot do anything with this. From the first expression, at least we can do something here. x1 equal to, I can write 2 times of x2. Yes, we got the relation. That is what I want. So what is the conclusion here? This expression can be written as x1 x2 probably, right? So it can be directly written as, we can write x1, either நீங்க எப்படி எழுதலாம்? This relation can be written as x1 by x2 is equal to minus 2 by 1. Can I write like this? So x1 equal to minus 2, x is equal to 1. That is the ratio between them. I said you can also multiply by a scaling factor k1 and k2. If you want to do, if you want to multiply them, you can multiply that. If you want to multiply them, you can do it, right? And question like example, mostly its minimum value we are considering as 1. Its minimum value we are considering as 1, such that you will be tested with the direct answer, that is minus 2 1 அப்படினே கொடுத்திருப்பாங்க, right? It means they are considering least possibility, first வர ratio அப்படியே எடுத்துப்பாங்க, right? Anyway, what we got here? So here we got the answer as k10. Here my answer is k10, right? So similarly here the answer is what? Minus 2 1, right? So is there any difference between them? இப்போ இந்த வேல்யூ ஏதாச்சும் மல்டிப்ளை பண்ணா இதுல வரும், அந்த மாதிரி ஏதாச்சும் வருதா? No, right? So the conclusion is what? These two equations are always linearly independent each other. Linearly independent each other. So the conclusion is what? The conclusion is when we have distinct eigenvalues, அப்படினா மீனிங் என்ன? lambda 1 க்கு 4 வந்துச்சு, lambda 2 க்கு 3 வந்தது, கரெக்ட்டா? ரெண்டுமே டிஃபரண்ட் வேல்யூ தானங்க. when we have distinct different eigenvalues வந்துச்சு அப்படினா அதுக்கு கரஸ்பாண்டண்டா கிடைக்கிற eigen vector are always linearly independent each other. So next statement, put it in the box, right? Suppose, right, while finding, right, if you are finding the eigen vectors for, right, eigen vectors for distinct eigenvalues, distinct not different eigenvalues, right, distinct eigenvalues, then in the resultant set of vectors, right, set of vectors are going to be linearly independent each other. You cannot express, right? இதல இருந்து நம்ம இத கொண்டு வர முடியாது, இதல இருந்து இத கொண்டு வர முடியாது. லைக் இப்போ நான் என்ன சொன்னேன், நான் ஏற்கனவே சொல்லிருந்தேன் இல்லையா, x1 + x2 = 0 னு ஒரு ஈக்குவேஷன் இருக்கு. இன்னொரு ஈக்குவேஷன் வந்து 2x1 + 2x2 = 0 அப்படினு இருக்குனா இதுல மீனிங் என்ன? ஃபர்ஸ்ட் எக்ஸ்பிரஷனை 2 ஆல மல்டிப்ளை பண்ணா செகண்ட் ஈக்குவேஷன் வருது. தட் இஸ் கால்ட் தி லீனியர் டிபெண்டன்சி. Such type of relations cannot be possible in between them. So that is called what? Linearly independent vector. So the conclusion is, whenever we have right distinct eigenvalues, then its correspondent eigenvectors are going to be always linearly independent each other. I hope things are very clear to you all, right? Okay. So try to understand these things because that is very important, right? So let me rub this one. Let us rub this one. Okay. So this is how we are finding eigenvalues and the eigenvectors, right? Let us see the possibilities. You can do the same thing for 3 cross 3 matrix. Anyway, just giving the procedure, right? The 3 cross 3 matrix. If you have 3 cross 3 matrix, right? How to find out the eigenvalues? Procedure will be remain same. But I said there are two models to find out the characteristic equation, right? 3 cross 3 matrix கொடுத்திருக்காங்க அப்படினா, for example 1 2 3 4 2 1 5 1 2 இந்த மாதிரி ஒரு மேட்ரிக்ஸ் கொடுத்திருக்காங்க வெச்சுக்கோங்க. With this we can consider x1 x2 x3 of course, and you can just equal it to 0. Guys, matrix B a கொடுத்தாலும் you don't need to consider. I'm repeating once again. B is what? It is the input signal. That signal will going to drive your system. Our target is system property. That's what I am doing here. Okay, fine. Take this one. This is my matrix A. 3 cross 3 matrix. Its corresponding characteristic equation is lambda cube minus A times of lambda square plus B times of lambda minus C equal to 0. Once again, A is what? Sum of principal diagonal. Sum of principal diagonal only, right? So A is sum of principal diagonal, right? Whereas second, B is, once again listen, while going with B, we have to find out the right sum of determinant of, right, that is determinant of subsquare matrix of the principal diagonal, right? So sum of the determinant of the right subsquare matrix of the principal diagonal, right? So sum of the principal diagonal of the subsquare matrix, right? Guys, listen, once again we have to write, let me write like this, sum of, right, sum of determinant of subsquare matrix, right? So determinant of subsquare matrix of principal diagonal, right? So that is going to be principal diagonal, right? So that is going to be principal diagonal. Okay, fine. Next select C. C is going to be the determinant of the matrix. C is going to be the determinant of the matrix. Okay, fine. See, remaining procedure remains same. That is one model. Or you can also go with in order to find out the characteristic equation, directly you can proceed. A minus lambda I said, right? Proceed with this. A minus lambda equal to 0 போட்டு நீங்க அப்படியே நீங்க சால்வ் பண்ணீங்கன்னா you will get the equation, right? So that is alternative way to obtain the value of characteristic equation. இத ஃபைண்ட் பண்ணதுக்கு அப்புறம் you have to find out the determinant. That is very important, right? Find out the determinant of A minus lambda I, or just go ahead with this procedure. Anyway, how will you find C? Sum of determinant of subsquare matrix. C. நம்ம என்ன பண்ணுவோம்? Sum of the determinant of subsquare matrix of the principal diagonal அப்படினா how will you do it? Let us see sum of principal diagonal. Principal diagonal is what? Guys, listen. Diagonal values sum to add பண்ணுங்க. See, the first one is sum of principal diagonal அப்படினா 1 plus 2 plus 2 is going to be 5. Second one is sum of determinant of subsquare matrix. See, first நீங்க என்ன பண்ணனும் அப்படினா determinant subsquare matrix. Once again, wait a minute. Principal diagonal matrix select பண்ணுங்க. See, the first element select பண்ணி neglect its correspondent column under row. Neglect பண்ணிட்டு, that is going to be the subsquare matrix of the first principal element, right? Here the subsquare matrix oda determinant எவ்வளோ 4 minus 1 will going to be 3 plus I said what, sum of determinant of subsquare matrix of the principal diagonal, right? அதே மாதிரி second principal diagonal diagonal elements. Second diagonal choose பண்ணுங்க. If I am going with the second diagonal is this one. Neglect its correspondent column under row. Subsquare matrix 4 5 1 2. என்ன பண்ணுவீங்க? 4 into 2 8. 8 minus 5 will give you 3. 8 minus 5 will give you 3. Press. Select the third principal, this one, right? Let me remove rest of things, right? Neglect its correspondent row and column. Subsquare matrix is this one. It's going to be what? 2 minus 8. 2 minus 8 will give you minus 6. Anyway, in this case that is 0, right? Fine. Just to understand the procedure, right? That's enough. Determinant of the matrix, Determinant in the sense we know what to do, right? That is 1 into, let me rub this one. This is 2, right? Now you can proceed further. Okay, let's see what happened. 1. Determinant is going to be, let's see, that is, okay, 4 minus 1 is going to be 3, minus 2 into 8 minus 5 is 3, plus 3 into 4 minus 10 is going to be minus 6, right? That is minus 2, that is minus 6. Here what we got? Okay, wait, 3 minus 6 minus 8, such that it is going to be what? Minus 6 plus 3 minus 3 minus 3 minus 8 will become minus 21, right? So the answer is what? Minus 21. Now substitute all these values here, you will get the third order equation. Guys, listen, we all know above second order we don't have direct procedure to find out the eigenroots of the eigenvalues. Like characteristic equation are third order system. Third order system, actually up to second order system we have the standard procedure, quadratic equation use panni we can find out the corresponding roots exactly. Third order equation there will be no direct procedure till now in this universe. No one found the exact procedure in order to find out the solution or in order to obtain the eigenvalues for the third order equations. Appo enna pannuvaanga exam la third order equations pathi, I mean 3 cross 3 matrix kudukranga appadina definitely with that they will give you some other clues in order to crack this equation. In the 3 equation 3 eigenvalues la edachu or eigenvalue kuduthruvaanga அப்படினா டைரக்ட்டா 3 cross 3 matrix la ஒரு eigenvalue கொடுத்துட்டு அதோட eigenvectors கேட்பாங்க. அப்படி தான் உங்களுக்கு கேட்பாங்க. directly you are not being tested in order to find out this value. அப்படி இல்லனா there will be one more procedure will be there, that is synthetic division. Long division rule வச்சு நீங்க ஃபாலோ பண்ணிருப்பீங்க, ரைட்? அதாவது trial and error procedure. Wait a minute. Trial and error procedure la போடிங்க அப்படினா it will be tedious task, right? But there will be one more procedure, right? That procedure is you are supposed to go with the synthetic division, like 1. இப்போ நீங்க ஒரு எனக்கு ஒரு ஈக்குவேஷன் வந்திருக்கு, அதோட வேல்யூ வந்து இப்போ 1 2 3 இந்த மாதிரி வருது அப்படினா ஃபர்ஸ்ட் ஸ்டெப் இங்க 0 போட்டு நீங்க ப்ரோசீட் பண்ணுவீங்க இல்லையா? இங்க இருக்க வேல்யூ அப்படியே இங்க கொண்டு வந்துட்டோம். we have to go with the trial and error procedure. இப்போ இங்க 1 போட்டா லாஸ்ட் வேல்யூ 0 வருமா, இல்ல 2 போட்டா லாஸ்ட் வேல்யூ 0 வருமா, இல்ல -1 போட்டா 0 வருமா, இல்ல -2 போட்டா 0 வருமா, like that only you can solve, right? So that is one of the procedure, but with this procedure you cannot find out the complex roots. That's actually you can do, but you cannot எக்ஸாக்ட்டா வந்து அந்த டைம்ல எந்த வேல்யூ வருது அப்படிங்கறத உங்களால ஃபைண்ட் பண்ண முடியாது. So they won't be testify with this type of equations. Clearly it will be given with some clues, then you can crack it. Don't be panic when we are facing that is third order equations, right? By solving the problem I will explain அவங்க எப்படி क्वेश्चंस எடுத்துக்காங்கறத நான் காட்டுறேன், then you will get the idea, clear idea. Okay, so that's all. Rest of procedure all remains same. Once you find the characteristic equation, then we know from this we have to obtain the eigenvalues. Once we find the eigenvalue, then our next target is we have to obtain the value of eigenvectors. Okay, same procedure, there will be no changes. Okay, fine. So let me run this one. By solving the problem I will explain 3 cross 3 matrix applicated on, then you will get the clear idea. Don't be panic, right? So right now I don't want to waste my time. Fine. So this is all about 3 cross 3 matrix. Now let us talk about the properties of eigenvalues and eigenvectors, right? So what I have understood, the first thing is, listen, eigenvalues and eigenvectors அப்படினா the thing is, now we know what do you mean by eigenvalue and what do you mean by eigenvector, right? So the property number 1, right? So the first property number 1 is we saw something. நம்ம என்ன பார்த்தோம் அப்படினா when we have distinct eigenvalues lambda 1 lambda 2 etc up to lambda n, all are distinct eigenvalues. They are called distinct, right, eigenvalues. If your eigenvalues are distinct அப்படினா different to each other, ஒரே values வரது அர்த்தம், different value 1 2 3 4 5 6 -1 -2 -3 like that, right? So if you have distinct eigenvalues, for distinct eigenvalues its correspondent eigenvector is what? Its correspondent eigenvector, right? Its correspondent eigenvector, right, is linearly independent each other. That is eigenvector is become linearly, so we can write linearly independent. Already I wrote, that is I have given the proof for this one, right? So that is going to be linearly dependent. So right, second case, the second property is, suppose if lambda 1, right, lambda 2 etc lambda n are repeated. If I have repeated eigenvalues, if you have repeated eigenvalues, if your eigenvalues are being repeated, then enna answer enna? Its correspondent eigenvector enna pathom, its correspondent eigenvector, maybe we cannot give assurity for that, it might be linearly dependent or linearly independent, right? So linearly dependent or independent, we cannot give assurity for that. Okay, that things is this is not known for us. It might be linearly dependent or linearly independent or clear. Make very clear statements because it will be tested for some worthless theoretical questions. Clear? Fine. So that is the first two properties, right? So let us see the third property. Okay, let me rub this one. Okay, let us see the third one is we have to consider the eigenvalues, right, within the matrix. Let me consider this one, right? Wait a minute. The thing is, if I have a real symmetric eigenmatrix, right? So the thing, real symmetric eigenmatrix. Apna meaning enna? Real symmetric eigenmatrix is this. For an example, I have 2 here, right? Just we have some values. Let us take 2 and 3, and let me consider 1 1. I have a matrix like this, right? That is my matrix, real symmetric matrix, right? And if I am trying to find out A transpose, real symmetric na meaning enna? A transpose value enna varudhu parenga. A transpose will become 2 1 1 3. Am I getting same value? Yes. If A and A transpose are equal, then that is called real symmetric matrix. Since all the values are real only now, whereas a real and the matrix is symmetric, such a type of matrix are called real matrix as well as symmetric matrix. So that is called real symmetric matrix, right? If your matrix is real and symmetric, right? If your matrix is real and symmetric, then you have to, you are requested to find out its correspondent eigenvalues, right? For real and symmetric matrix, right? Next step, find out its eigenvalue, right? Right? It will provide, right, with this eigenvalue, right? Find out the eigenvalue for the real symmetric matrix. With the eigenvalue, you are requested to find out the eigenvectors. With the eigenvalue, you are requested to find out the eigenvectors. Those eigenvectors are always, right, orthogonal, right? So those eigenvectors are always orthogonal. I hope things are very clear to you all. நான் என்ன சொல்ல வரேன் அப்படினா ஒரு மேட்ரிக்ஸ் வந்து ரியல் அண்ட் சிமெட்ரிக்கா இருக்கு அப்படினா அந்த மேட்ரிக்ஸோட eigenvector வந்து orthogonal இருக்கும். That's all. We know what I mean by orthogonal. X1 transpose at x2 will become 0. I have given the conclusions, right? Some theoretical point of view you have to observe. See, if you find any matrix like that, you can test it by yourself, right? Find out the eigenvalue and then find out the eigenvector. Check its orthogonality. Orthogonality in the sense x1 transpose dot x2 will be equal to 0. Clear? So that is called eigenvectors, or that is orthogonality of the given vectors, right? That is some of the properties that we are observing from the matrix. Observations. This is not what I can say inventions at all. Observations. So matrix is solved in a it is being like that, right? That's all. There are no big things to observe, right? Yes. So next thing is, let me run this one. Let us observe some other properties of the eigenvalue. For that, we have to talk about real matrix and right, what I can say imaginary matrix, right? Now when we are talking about real and imaginary matrix, right, so that is called transgate matrix. Let me talk about first one. Now let us discuss about real matrix, and then I am going to talk about two persons now. One is, one second guys, real matrix, another one is transgate matrix. We are going to talk about two people now. Transgate matrix. What is the difference between real matrix and the transgate matrix? I know we are discussing about some theory in depth, right? So just you should try to understand. There are no big things. Transgate in the sense, it will be the combination of, that is transpose plus conjugate. That is called transgate. Transpose plus conjugate matrix are called transgate matrix, right? Whereas real matrix in the sense purely real. There is no imaginary values or complex values, right? It will have only real values. For a real matrix, it can be classified, right? So first one, real matrix it might be symmetric, right? A real matrix is said to be symmetric, right? When, for example, a matrix A is given, right? In that matrix, while finding the A transpose, A and the A transpose are become equal. Then that matrix is called real matrix. Right now, why I am talking about this person under eigen and eigenvalues? Why? Because we are looking for the properties of eigenvalues and eigenvectors, right? So the conclusion is, if your matrix is real and symmetric, if your matrix is real and symmetric, then conclusion is, for a symmetric matrix we can write, for a symmetric matrix, right, its eigenvalues, it's always purely real, right? Eigenvalues, right, of symmetric matrix, right, eigenvalues always purely real. Let me write, always purely real, right? It is purely real. Clear? That is the statement that I would like to conclude when we have a symmetric matrix. Guys, listen, I am repeating. So this is no proof கிடையாது. இதெல்லாம் வந்து observations. ஒரு மேட்ரிக்ஸ் வந்து சிமெட்ரிக்கா இருந்தது அப்படினா அது eigenvalues செக் பண்ணி பார்த்தா எப்பவுமே ரியலா தான் வருது. எத்தனை சிமெட்ரிக் மேட்ரிக்ஸ் இருக்கலாம்? That's why I'm directly writing these things. If I want to prove it, I have to take some 10 symmetric matrix, I have to prove. Unnecessary things, you can do it by yourself, right? Because we have to understand, that's enough. Next, this is symmetric matrix. Let us talk about skew symmetric matrix, right? Next type of matrix is called skew. Already we have been concluded, right? So basic classification we have paathirukom. Skew symmetric matrix na enna? A is equal to minus A transpose. Yes or no? Yes. That is called skew symmetric matrix. With the proof I have given these things there, right? If your matrix is skew symmetric, that is a skew symmetric matrix, then its eigenvalue, right? Its eigenvalue always, its eigenvalue is always purely, guys, very important, right? So purely imaginary or zero, clear? I hope things are very clear. That is the property of skew symmetric matrix, right? So let us discuss about one more person here. Is it going good? I came out, right? Class is going on? Yeah, it's going great. Let's continue. Next we should talk about orthogonal matrix, right? So symmetric, skew symmetric. Next we should talk about orthogonality, right? Orthogonal matrix. Orthogonal in the sense, a matrix is said to be orthogonal when the product of A dot A transpose will become equal to the value of unit matrix. And the product of A dot A transpose. Guys, many of you guys are having a doubt here, right? Mistakes. என்ன mistake பண்ணுவீங்க அப்படின்னா, நீங்க எல்லாரும் என்ன நினைச்சுக்கிறீங்கன்னா A dot A inverse ஓட வேல்யூ என்ன வரும் அப்படின்னா யூனிட் மேட்ரிக்ஸ் தான் வரும். நீங்க இது ரெண்டும் ஒண்ணு நினைச்சுக்கிறீங்க. That is wrong actually. See, A dot A inverse னா மீனிங் என்ன? நான் சும்மா கேக்குறேன். x power 1 x power minus 1 கூட மல்டிப்ளை பண்ணா x power 0 தான் வரும். அது 1 தான் எழுதுவீங்க. But this is not the condition for orthogonality, right? இது நார்மல் ப்ராடக்ட்ங்க. அதுல நீங்க யூனிட் மேட்ரிக்ஸ் தான் வரும். ரெண்டு மேட்ரிக்ஸ் இருக்கு. ஒன்னு வந்து A, இன்னொன்னு வந்து A இன்வெர்ஸ்னா ரெண்டுத்தையும் மல்டிப்ளை பண்ணா I தான் வரும். Is there any mistake? No, that is correct only. But அதுவும் இது ஒன்னு கிடையாது, right? The condition is orthogonality அப்படினா மீனிங் என்ன? இதோட correspondent vectors product are going to be 0, right? X transpose, that is x1 transpose dot x2 or x1 dot x2 transpose will going to be equal to 0. That is called orthogonality. Orthogonal vectors, orthogonal matrix அப்படினா A dot A transpose இவங்க ரெண்டு பேரோட வேல்யூ வந்து ஈக்குவல் டு I வந்துச்சுனா yes, that matrix. இந்த மாதிரி ஒரு மேட்ரிக்ஸ் வந்து என்ன பண்ணும் அப்படினா orthogonal properties satisfy பண்ணுது. Observations சால்வ் பண்ணி பார்க்கணும். ஒரு மேட்ரிக்ஸ் வந்து A வை A டிரான்ஸ்போஸ் எந்தெந்த மேட்ரிக்ஸ்லாம் A வை A டிரான்ஸ்போஸ் மல்டிபிள் பண்ணும்போது யூனிட் மேட்ரிக்ஸ் வருதோ அந்த மேட்ரிக்ஸ் தான் ஆர்த்தோகனலா இருக்கு. அப்சர்வேஷன். If all you guys are thinking like that, A dot A transpose equal to I வந்தா that is orthogonal matrix. அந்த கன்க்ளூஷனுக்கு நீங்களே வந்துருங்க. That is wrong actually. That is not true, right? Right, fine. Let's continue. Orthogonal matrix in the sense this is the true value. Now my question is what its correspondent eigenvalue, right? Its eigenvalue, right? Its eigenvalue is what? Since this matrix is equal to what? Unity, right? So since its matrix is equal to unity in the sense, it is going to be what? Purely 1, right? So it is going to be purely 1. When we are looking for its correspondent eigenvalue, it is going to be purely 1, right? So at the same time, I would like to determine the determinant offered by this matrix. Determinant to not determinant, right? So wait a minute. I will define its correspondent determinant also, right? So determinant of n over the thing is its determinant is going to be, let us see, if you want to find out the determinant of A dot A transpose, that is equal to mod I. Determinant of I, let us see, determinant of A dot A transpose can be written as determinant of A dot determinant of A transpose equal to mod I. But we all know the property, determinant of A will always be equal to determinant of A transpose. Do you remember? Property of determinant already defined, right? So determinant நம்ம என்ன பார்த்துட்டோம்னா ஒரு மேட்ரிக்ஸ் நீங்க டிரான்ஸ்போஸ் எடுத்துட்டு நீங்க determinant find பண்ணனும், அதே வேல்யூ தான் வரும், right? So the conclusion is A transpose can be replaced by A such that determinant of A dot determinant of A will become determinant of A square, whereas determinant of I is equal to 1 such that determinant of the orthogonal matrix should be equal to plus or minus 1. Clear? Square அந்த பக்கம் பாஸ் பண்ணீங்கன்னா that will become square root, right? That is plus or minus 1, right? So what is the conclusion here? Determinant of the orthogonal matrix are always equal to what? Plus or minus 1. Clear? Similarly, let us discuss about conjugate matrix. Conjugate adina what I had been told you, it will be the combination of transpose plus conjugate, that is called a conjugate matrix. Yes. So in case of conjugate matrix, right? So first thing is first we should talk about Hermitian matrix. இங்க நம்ம symmetric அப்படி டிஃபைன் பண்ணோம் இல்லையா, அதே விஷயம் guys listen. What I mean by conjugate matrix? அப்படினா meaning என்ன? First you have to take conjugate and then you have to take transpose. It can be simply defined as conjugate matrix. Conjugate அப்படினா meaning என்ன? First of all listen. Conjugate in the sense for the given matrix you have to take transpose and then you have to take conjugate, or you have to take conjugate and then you have to take transpose. That is called conjugate matrix. Transpose plus conjugate, right? So let us look at the properties of conjugate matrix. First one is first type of matrix, Hermitian matrix, right? First type of matrix is called Hermitian matrix. It is same as symmetric matrix. Real la வந்து நம்ம symmetric எப்படி டிஃபைன் பண்ணுமோ அதே மாதிரி conjugateல Hermitianம் symmetric ஒண்ணுதான், right? அப்ப இங்க என்ன வரும் அப்படினா Hermitian matrix in the sense we have to define like this: A is equal to A power theta, whereas theta denotes what? Transpose conjugation. This is A theta, right? So what is the conclusion? If your Hermitian matrix satisfies, that is conjugate matrix satisfies this condition, then that matrix is called Hermitian matrix, and its corresponding eigenvalue will always be purely real, right? Its corresponding eigenvalue will always be purely real because it is same as symmetric matrix. Here also, though we are talking about transfer and conjugate complex variables at all, if it satisfies the properties of Hermitian, that is symmetric, see this property வந்து satisfy பண்ணுது அப்படினா அந்த eigenvalue purely real ஆ இருக்கும், right? See, do remember eigenvalues properties for Hermitian and skew Hermitian, like symmetric and skew symmetric. While talking about orthogonality, remember the property of determinant, because theoretically it will be tested for these questions, right? That's very important, right? I think class is going good. This is Hermitian. Let's talk about skew Hermitian matrix. Let us discuss about skew Hermitian matrix, like skew symmetric matrix, But I know Hermitian matrix in the sense that can be defined as A minus, that is A is equal to minus A conjugate, that is conjugate, not conjugate, conjugate, that is transpose plus conjugate, right? So it is same as what? Anga நம்ம என்ன பார்த்தோம்? A is equal to minus A transpose. If any matrix satisfies this condition, then its correspondent eigenvalues, என்ன எழுதுறீங்க? Its correspondent eigenvalues can be defined as, right? It may be what? Purely, the answer is it may be purely imaginary, or zero, right? Or it may be purely imaginary or zero. Similarly, when we are looking for conjugate matrix, we have to define orthogonality. Once again, we should talk about the final answer is for conjugate matrix. We should talk about orthogonality, right? If you want to talk about orthogonal matrix, right, same property that we saw for what? Real matrix. So the conclusion is for here you will get A dot A power theta will become I, such that it's what I can say determinant also going to be what? Plus or minus 1. You will come up with the same relation. Clear? Yes. Fine. I hope things are very clear to you all, right? Just do remember, that's enough. This is all about what I can say that is conjugate matrix and symmetric matrix, right? And next conclusion. Let me rub this one. The next one is we should, if I combine, இப்போ நீங்க வந்து என்ன சொல்றீங்கன்னா practically ஜெனரலா எந்த ஒரு மேட்ரிக்ஸ் கொடுத்திருந்தாலும் அப்ப அந்த மேட்ரிக்ஸ் என்ன இருக்கலாம் அப்படினா ஒரு மேட்ரிக்ஸ் கொடுத்திருக்காங்கன்னு வெச்சுக்கோங்க உங்ககிட்ட. ஒண்ணு அந்த மேட்ரிக்ஸ் சிமெட்ரிக்கா இருக்கணும், இல்ல அந்த மேட்ரிக்ஸ் வந்து ஏசிமெட்ரிக்கா இருக்கணும். இது ரெண்டுத்துல ஒண்ணா தான் இருந்தாகும். கரெக்ட்டா? எஸ். So whichever the matrix in general we can define, right? So the given matrix can be expressed as the sum of, right? So any matrix can be expressed as the sum of symmetric plus asymmetric, right? So the next conclusion is ஏதாச்சும் ஒரு மேட்ரிக்ஸ் வந்து கொடுத்திருக்காங்க அப்படினா see in signals and system, when I was talking about the properties of even signal and odd signal, we have been concluded three type of signals. Either you can consider purely even signal, or we can talk about what I can say odd signal property பார்த்தோம். But practically it is like a signal it will be the combination of, it is neither even nor odd, but it will be the combination of even and odd signal. Do you remember? Same thing. But in matrix we are seeing those things, right? So the conclusion is a generalized matrix can be expressed as the sum of symmetric plus skew symmetric. அங்க நாம என்ன பார்த்திருப்போம்? இதுக்கு பதிலா symmetric க்கு பதிலா a1, skew symmetric க்கு பதிலா anti signal, that is called what? Odd signal. So any signal can be expressed as the sum of what? Even plus odd signal. So any matrix can be expressed as the sum of what? Skew symmetric plus symmetric. Any mistake in my conclusion? No. But here I am defining in terms of matrix. That's all, right? So any matrix. So the next conclusion is any matrix, right? Any matrix, right? in bracket we can say just matrix A, right, can be expressed, right, can be expressed as, right, can be expressed as sum of what, symmetric and skew symmetric, right, can be expressed as the sum of symmetric and skew symmetric matrix. It will be the combined, right, combination of these two, right. So the real thing, it will be the combination of so the conclusion is generally if I have a matrix like this, right, or matrix in the it can be expressed as, let me write like this, a transpose, right, we can consider like this, that is A plus A transpose by 2, right, we can write, plus we can write A minus A transpose divided by 2, such that if I add these two equations, this is add A transpose by 2 minus A transpose by 2 getting cancelled, A by 2 plus A by 2 will be equal to A, right. So this is equal to this one, right. So any matrix can be expressed as the sum of symmetric plus skew symmetric matrix. Clear? That's all. That is the next property of your symmetric matrix. That is the general matrix. Okay. Okay. Let us see some other properties of your eigensignals. Let me run this one. Guys, in this area you will be often tested theoretically. That's why I am giving these things, very important, right? All observations only, just to make very clear notes, right? Next, let us see some other properties of your eigenvalues, right? So the next property of your eigenvalue is, right, eigenvalue should be equal to, right? So first thing is, next one is eigenvalue of a matrix is equal to, right? Eigenvalue of a matrix is equal to sum of principal diagonal, right? Sum of principal diagonal. See, நம்ம எல்லாருக்கும் என்ன தெரியும், eigenvalues எப்படி கொண்டு வரலாம் அப்படிங்கிறது நமக்கு தெரியும், right? eigenvalues ஃபைண்ட் பண்ணதுக்கு அப்புறம் அதை எடுத்து ஆட் பண்ணீங்க அப்படினா that should be equal to sum of principal diagonal. அப்படினா மீனிங் என்ன? For an example, you can take any example, right, that you want, but understand, example எடுத்தீங்கன்னா அப்படினா, for an example, let me select some matrix. What shall we do? 9 2 0 1. Let us select some matrix A. Now find out the eigenvalue for this matrix. Eigenvalue என்ன நமக்கு, that is lambda square minus A, that is A times of lambda plus B equal to 0. What is the value of A? A is sum of diagonal, so 9 plus 2 will become 11, 11 times of 2, right, plus B is what? Product of these two, that is B is determinant of the matrix, determinant in the sense product of these two minus product of these two, such that it is going to be 18 equal to 0, right. Now can you break them directly? Of course we can break. How? 9 times of 2 will be 18, so minus 2 minus 9 minus 2 will give you what I can say minus 11, such that this matrix can be written as minus 9 and lambda minus 9, lambda minus 2 can be written like this. So eigenvalue is going to be lambda equal to 9, lambda 1, lambda 2 equal to 2. If I add these two, see there, what is the conclusion here? We can write lambda 1 plus lambda 2 is equal to 9 plus 2 is equal to how much? 11. Add the principal diagonal values, add pannunga, 9 plus 2 I am getting same value. So what is the conclusion, right? Eigenvalue of a system should be equal to what? It is sum of principal diagonal, right? Now I will do one more thing. இவங்க ரெண்டு பேரையும் மல்டிப்ளை பண்ணுங்க. Find out the determinant of this matrix. Determinant of the matrix should be equal to 9 into 2 18 minus 0 into 1 0, such that its determinant equal to 18 only. Now find the product of lambda 1 and lambda 2. Lambda 1 and lambda 2 multiply பண்ணா எவ்வளவு வருது பாருங்க, that is also equal to 18. What is the conclusion? So eigenvalue should be equal to sum of principal diagonal, that is the conclusion is what? Sum of eigenvalue is equal to sum of principal diagonal, right? So let me rub these things, right? Let us write the statements clearly, right? So the next property of the eigenvalue is sum of eigenvalue should be equal to, see, I forgot to insert sum here, right? Listen guys, just insert sum of eigenvalue should be equal to what? Sum of principal diagonal, right? Similarly the second statement is, right, the second statement is product of eigenvalue should be equal to what? Product of eigenvalue, right? So product of eigenvalue should be equal to determinant of the matrix. Do you agree with me? Yes, that is equal to determinant of matrix, determinant of the matrix, that's all, that is equal to determinant of the matrix. Very very important, please you should try to keep, because many times in your examinations directly you will be tested for some worthless 2 more questions. இந்த ரெண்டு ஸ்டேட்மெண்ட் வச்சு நீங்க சால்வ் பண்ணி ஈகன் வேல்யூஸ் கொண்டு வர மாதிரி இருக்கும். என்ன சொல்லிருப்பாங்கன்னா determinant of the matrix will be given, and the principle of diagonal will be given. You are requested to find out the eigenvalues. By solving this equation, you have to find out the value of lambda 1, lambda 2. Actually, இங்க என்ன இருக்கும், right? Determinant in the sense that should be equal to product of the eigenvalue. ஒரு 2 cross 2 matrix கொடுத்திருந்தாங்கன்னா lambda 1 into lambda 2 is equal to determinant. அதே மாதிரி principal diagonal கொடுத்திருந்தாங்க அப்படினா lambda 1 plus lambda 2 is equal to, right, some other value. You have to solve these two expressions in order to find out the answer. Right, so like that you will be tested in the examination, so do remember this property, that is very important, right? And let us consider the next one. Guys, listen, I have matrix A, its corresponding eigenvalue is given as lambda. Now I would like to know the value of A square. What will be the answer? Right, the question is, if for your A, if you are getting lambda whereas for A, if you are getting eigenvalue as lambda, then for A square its corresponding eigenvalue will be lambda square. Then for A cube, observations, I am directly writing these things, I don't want to waste my time. If you want to write, you can just take some matrix. Now last எடுத்தல அந்த matrix நீங்க எடுத்துக்கலாம், 0 2 எடுத்துட்டு find out the eigenvalue of this matrix, and then இதுல A square ஓட வேல்யூ ஃபைண்ட் பண்ணுங்க. A square அப்படினா find the A dot A matrix. இந்த matrix 2 times multiple பண்ணிட்டு அதுக்கு நீங்க eigenvalue ஃபைண்ட் பண்ணீங்கன்னா you will get the answer. There are no big things to understand, that's why I am writing the answer directly. Like that, if you want to know the value of A inverse, என்ன பண்ணுவீங்க? A inverse equal to lambda inverse. See, for A I am getting lambda, for A square I am getting lambda square, then for A power 3 I am getting lambda power 3, for A power minus 1 I am getting lambda power minus 1, or I can write 1 upon lambda. Any mistake? No, right? So next, if I am raising A power n, then its correspondent generally we can write. That's all. Clear? That is how we are defining, right? So similarly, when we are looking for adjoint of A, for A its correspondent eigenvalue is lambda, then for adjoint of A its eigenvalue is determinant of A by lambda. Very very important property, many of you guys are forgetting these properties. All our observations only, should try to keep it in your mind, right? Yes, that's all. Okay, that is the next property of your eigenvalue. I hope things are very clear to all, right? Now let me rub these things, right? Let us rub this one. eigenvalues ஓட ப்ராப்பர்ட்டிஸ்ல நிறைய क्वेश्चंस இருக்கும், right? நீங்க ப்ராப்ளம் சால்வ் பண்ணும்போது உங்களுக்கே தெரியும், right? Yes, so let me rub these things. What is our next task? Yes, we found the value of properties of the eigenvalues, right? Now similarly, இதுவரைக்கும் நான் பேசுனது எல்லாமே eigenvalues தானே. இதே மாதிரி eigenvector பத்தி பேசுனீங்க அப்படினா, see there the property for your A its correspondent eigenvalues x1, eigenvectors. A ஓட correspondent eigenvectors வந்து x1, x2 அப்படினா, for A1, for A2, for A3, for A power 4, for A power minus 1, for A power minus 2, for adjoint of A, right? All are same as, right? A only. So what is the conclusion? Eigenvector of the matrix won't be changed, it will be remain same, only eigenvalue will change. Don't forget, eigenvector of the system won't be changed. Observations, I am repeating all observations. You can take small matrix, 2 cross 2 matrix, you can cross check all these things, you will come to know whether it is true or not. Okay, fine. So this is the property of eigenvector, and this is all about the property of eigenvalue. I hope things are very clear to you all, right? So let me rub these things, right? The next thing is, at sometimes you will be tested for, right? You are requested to find out the number of free variables in the system, like number of independent variables அப்படினு கேட்பாங்க, right? ஒரு மேட்ரிக்ஸ்ல நீங்க எடுத்துக்கும்போது ஒரு மேட்ரிக்ஸ்ல எத்தனை வேரியபிள்ஸ், right, வந்து இண்டிபெண்டண்டா இருக்கு, right? number of independent variables அப்படி கேட்டாங்க அப்படினா how will you find out, right? So the thing is, number of independent variables அப்படிங்கிறது, that is nothing but free variables. They are called free variables. They are simply called nullified, right? That is some people are calling this nullified னு சொல்வாங்க, right? அப்படினா மீனிங் என்ன அப்படினா, those variables are not going to play with any components, right? So the conclusion is free variables, they are simply called free variables. Some people are calling it as what, that is independent variables, right? Wait a minute. Let me write, that is free variable. Free variable, we can also call it as independent variables. Independent variables. Some people are wait a minute. Independent variables. Some people are calling it as nullity, right? Let me nullity or nullify, right? So nullity, right? Next, some people are calling it as dimension of null space. right? That is the dimension of null space, dimension of null space. These people are equal to, we can simply find out this answer should be equal to number of observation once again, that is number of column, simply it can be written as number of column, right, minus rank of the matrix, rank of matrix. ஒரு சிஸ்டம்ல எத்தனை ஃப்ரீ வேரியபிள்ஸ் இருக்கு அப்படிங்கறத நீங்க ஃபைண்ட் பண்ணனும் அப்படினா that is free variables independent, யாரை டிபெண்ட் பண்ணிருக்காது, அது பாட்டு ஃப்ரீயா, that is randomly it's traveling in its own path, right? That is called a nullity. It is not depending on anyone, it's traveling its own way, right? So they are not depending on each other. So if you want to obtain these free variables or dimensions of null space, that is simply called, that is அது எப்படி obtain பண்ணுவீங்க? So for example, I have a matrix. Wait a minute. Let me take null matrix for understanding. Let me take null matrix, right? I know that is null matrix. Find out, the question is for dimensions of null space, right? இதுல find out பண்ணலாமா? இப்போ உங்களுக்கு புரியும், right? So it's null space equal to, எல்லாமே null தானே, it's null space equal to, I said what is the formula? Number of column. How many columns are there? Column 1, column 2, column 3. So total I have 3 columns minus, what about the rank of the matrix? Is it 0? Why? Rank in the sense number of non-zero rows. How many non-zero rows are there? No. So that is equal to 0, right? So the conclusion is that is equal to 3, right? Null space in the sense, in this entire system is what? Null. That is called null space or free variables. They are free from other people, right? So that is how we are finding the null space or dimensions of null space or independent variables or nullity or free variables. Don't forget. Like that you can also take some other examples, but this is the best example, right? Here only you get the highest value for this, right? But don't forget this property I said, I am repeating once again, because these observations are will be tested in your examination for worthless 1 mark or 2 mark questions will be directly tested, especially in PRB at all, right? 1 mark questions will be directly taken from these areas, right? Yes. So make very clear notes, that's very important. Fine. So let me rub this one. I hope things are very clear to all, right? I have solved many examples, right? Example questions are there. I said in matrix, right? Each and every exams you can select any exam you know, we can find many questions are there because its application is very vast. There are millions and millions of applications are there in this universe, right? Including electrical engineering, in the subject point there at some places there might be application of, you can see the application of mathematics, right? That is matrix. Fine. So this is all about eigenvalues and eigenvectors of the system, right? Now what is the next target? Once you find this all people, right? So we have seen the equations for dependent systems and independent systems, right? Orthogonal vectors, orthonormal systems, normality vector, eigenvalues, eigenvectors have been concluded, right? Rank of the matrix is over, determinant end up on the right? So all these things have been completed. Now finally the next task now we are going to do is we are looking for the solution of what I can say, higher order equations, higher order systems, right? If I have ஒரு higher order system இருக்கு அப்படினா அந்த higher order systems வந்து நம்ம எப்படி solution find பண்றது? See இப்போ நமக்கிட்ட என்ன இருக்கு அப்படினா matrix வேல்ல ஜெனரலாவே நமக்கு என்ன ப்ராப்ளம் அப்படினா a square ஒரு matrix a இருக்கு அப்படினா a square ஓட வேல்யூ வேணும், I can define. a cube at least we can define. a power 4 okay கொஞ்ச நேரம் டைம் ஸ்பெண்ட் பண்ணி a power 5 கொஞ்சம் டைம் ஸ்பெண்ட் பண்ண ஸ்பெண்ட் பண்றேன். a power 6 தான் சரி ஓகே நான் ட்ரை பண்றேன். a power 7 okay, a power 10 no, a power 15 no, a power 20 I cannot. How can you do? How many minutes I have to spend for that, right? Again people had started thinking matrix la edachu simplest way iruka or vandu edachu or different ana way adu eppadi irukkum appadina a power 50 a power 50 ku neenga ketta kuda or matrix eva enna kodutite a power 50 oda value a power 50 50 times neenga kekkreenga appadi ketta kuda என்னால வந்து ஒரு அட்லீஸ்ட் ஒரு 5 minutes to 10 minutes குள்ள ஆன்சர் பண்ண முடியும். அந்த மாதிரி ஒரு ஈக்குவேஷன் கொண்டு வந்தா நல்லா இருக்கும். இப்போ ஃபர்ஸ்ட் டைம் இந்த மாதிரி ஒரு ஈக்குவேஷன் மட்டும் கொடுத்தாங்கன்னா நீங்க சொல்லுவீங்க ஆன்சர் சார் தட் இஸ் இம்பாசிபிள். நோ, there was a person he spent that many hours, right? கரெக்ட்டா உட்கார்ந்து இதுக்காக டெவலப் பண்ணி he found one equation. We are using that equation in practice. That is called Cayley-Hamilton theorem. You all have remembered that, right? நீங்க engineering படிச்சிருப்பீங்க. You know the purpose? That's very easy, right? ஒரு a power 100 மேட்ரிக்ஸ் இருக்குனாலும் அந்த மேட்ரிக்ஸ்க்கு வந்து ஒரு 2 to 3 minutes அதுவும் அல்காரிதம்ல போட்டீங்கன்னா fraction of second your computer will give you the result suddenly. Proper algorithm will be there back, right? So the conclusion is what Cayley-Hamilton theorem beauty என்ன அப்படினா it satisfies its own every matrix. அவர் ஒரு ஸ்டேட்மென்ட் கொடுத்தாரு என்ன அப்படினா நீங்க எந்த ஒரு மேட்ரிக்ஸ் எடுத்தாலும் ஜஸ்ட் இமேஜின் பண்ணி பார்க்கறாரு ஒரு மேட்ரிக்ஸ் வந்து அதோட own characteristic equation satisfy பண்ணுதா இல்லையா அப்படினா மீனிங் என்ன ஒரு மேட்ரிக்ஸ் நம்ம கேரக்டரிஸ்டிக் ஈக்குவேஷன் டெவலப் பண்றோம். இப்போதான் நம்ம பார்த்தோம் இல்லையா செகண்ட் ஆர்டர் கேரக்டரிஸ்டிக் ஈக்குவேஷன் third order characteristic equation இப்போ நான் எழுதலாம்ல ஒரு eigen vectorsல eigen value ஃபைண்ட் பண்றதுக்கு நம்ம characteristic equation எப்படி எழுதணும் அப்படிங்கறத நான் தான் டிஃபைன் பண்ணேன். அப்ப அந்த ஈக்குவேஷன்ல அவர் என்ன சொல்றாருன்னா நீங்க அதுல வந்து ஒரு eigen value ஃபைண்ட் பண்ணுவீங்க இல்லையா, அந்த eigen value சப்ஸ்டிட்யூட் பண்ணும்போது டோட்டல் வேல்யூ 0 ஆகுதுல. அந்த characteristic equation சால்வ் பண்ணீங்கன்னா you are getting some eigen value. அவர் என்ன சொல்றாருன்னா each and every characteristic equation or matrix, right, each and every matrix will satisfy its own characteristic equation அப்படினு ஒரு ஸ்டேட்மென்ட் கொடுக்குறாரு. அப்படினா அவர் என்ன மீன் பண்றாருன்னா அவர் என்ன characteristic equation ஃபைண்ட் பண்றாரோ அந்த characteristic equation யாரோடது, ஒரு ஸ்பெசிபிக் நீங்க கொடுத்த மேட்ரிக்ஸ் ஓடது. அப்ப அந்த மேட்ரிக்ஸ்ல இருந்து அந்த characteristic equation நான் கொண்டு வந்தேன் அப்படினா அவங்க ரெண்டு பேருக்கு நடுவுல ஒரு ரிலேஷன் இருக்குல்ல. எஸ். அப்ப அதை வச்சு நான் என்ன பண்றேன்னா instead of going with the bulky matrix, நீங்க மேட்ரிக்ஸ் வந்து மேட்ரிக்ஸ் ஈக்குவேஷன் கொண்டு வந்தீங்கன்னா அந்த ஈக்குவேஷன்லயே நான் சால்வ் பண்றேன்ற அப்படிங்கறாரு. இந்த ஈக்குவேஷனை எங்க இருந்து கொண்டு வந்தீங்க, மேட்ரிக்ஸ்ல இருந்து கொண்டு வந்தீங்க, நான் இந்த மேட்ரிக்ஸ்லயே சால்வ் பண்ணி ஆன்சர் கொண்டு வந்து திரும்ப அந்த மேட்ரிக்ஸை கன்வெர்ட் பண்ணிக்கணும்னு சொல்றாரு. ரைட். ஆஃப் கோர்ஸ் that's it's working, right? That's the correct work ஆயிடுச்சு and we brought the result also, right? Let's talk about the final chapter of your matrix, that is called the Cayley-Hamilton theorem, right? So the next one we are going to discuss about Cayley-Hamilton theorem, right? So let us talk about Cayley-Hamilton theorem, right? Brilliant, right? Because of this scientist only your matrix will become very easy for us, right? So this Cayley-Hamilton theorem, it's quite interesting actually. If you see history, backlog or development, in free time you can read, you will come to know many things about it. Fine. Let's start our journey with the Cayley-Hamilton theorem, right? Is it simply the matrix statements la kudukanum appadina every matrix it satisfies its own characteristic equation, right? Every matrix, right? Every matrix will satisfies, right? Satisfies its own characteristic equation, its own characteristic equation, its own characteristic equation. That is what is called Cayley-Hamilton theorem. That's the beauty of this, right? Yes. Appadina meaning enna proceed pannalama. Yes. Now for an example, I have a matrix like this. Guys, listen, I have a matrix. Now a simple matrix எடுத்துக்கிறேன். ஒரு 1 2 1 என்ன எடுத்துக்கலாமா, 4 எடுத்துக்கலாமா. Yes. 1 4 5 1 into 4. Yes, I am getting value 0. Let us consider 3. Fine. Let us consider some value x1 x2, right? Okay. I think இது எல்லாமே தேவையில்லை, நம்ம டைரக்டா டிஃபைன் பண்ணிக்கலாம், right? I am just selecting a matrix. That's enough. அவர் டிஃபைன் பண்ணது சிஸ்டம் மட்டும் தான், ரைட்? சிக்னல்ஸ் இங்க ப்ராப்ளமே இல்லை. அந்த b அப்படிங்கிறது ஒரு சிக்னல், அவ்வளவுதான். அந்த சிக்னல் வச்சு நம்ம சிஸ்டம் இது பண்ண போறோம், டிரைவ் பண்ண போறோம். அவர் டார்கெட் இஸ் சிஸ்டம், ஒரு பிக் சிஸ்டம். அந்த சிஸ்டமை நீங்க எப்படி அனலைஸ் பண்ண போறீங்க, அதுக்கான ப்ராப்பர்ட்டிஸ் தான் நம்ம பார்த்துட்டு இருக்கோம், ரைட்? லெட்ஸ் see. இப்போ இதுக்கு மட்டும் நீங்க கேரக்டரிஸ்டிக் ஈக்குவேஷன் ஃபைண்ட் பண்ணுங்க. lambda square minus a times of lambda plus b equal to 0. Yes. So it can be written as lambda square minus a is what, sum of diagonal, that is going to be 1 plus 4 will be 5. So 5 times of lambda plus b, 1 into 4, b is what, determinant of the matrix. So 4 minus 0 will going to be 4 equal to 0, such that it's going to be what, it can be, guys listen, can you break it? Yes, 4, and here I can write like this. Can we get not 1 into 4 will be 4, right? But let us consider minus 1 minus 4, such that minus 1 minus 4 will give you minus 5, minus 1 into minus 4 will give you plus 4, such that it can be written as lambda minus, okay, that's enough. That's enough. Why I am going these many things? இப்போ அவர் என்ன சொல்றாருன்னா this is called the characteristic equation. அவரோட ஸ்டேட்மென்ட் படி see that every matrix will satisfy its own characteristic equation. This is my matrix, this is its correspondent characteristic equation. அப்படினா அவர் என்ன மீன் பண்றாரு அப்படினா டைரக்ட்டா மேட்ரிக்ஸை சால்வ் பண்றதுக்கு பதிலா இந்த ஈக்குவேஷன் இந்த மேட்ரிக்ஸ் இருந்தானே கொண்டு வந்தீங்க, அப்ப இது சாட்டிஸ்ஃபை பண்ணணும்ல. ஏன்னா ரெண்டு பேருக்கு ஒரு ரிலேஷன் இருக்கு இல்லையா, என்ன ரிலேஷன் இதுதான் இது. ஏன்னா நீங்க ஈக்குவேஷனா மாத்திட்டீங்க ஒரு மேட்ரிக்ஸை. அப்ப நான் என்ன சொல்றேன் அப்படினா அவர் என்ன சொல்றாருன்னா இங்க இருந்து இத ஃபர்தரா டெவலப் பண்ணுங்க, இதுல லாம்டாவுக்கு பதிலா சிம்பிளா a னை ரீப்ளேஸ் பண்ணுங்கன்னு சொல்றாரு. அகைன் ஈக்குவேஷனா சால்வ் பண்ணுங்க, அதுக்குள்ள மேட்ரிக்ஸ் இருக்கு, பட் அந்த மேட்ரிக்ஸ் இப்ப டச் பண்ண வேண்டாம். ஆனா அந்த மேட்ரிக்ஸ்ல இருக்க வேரியபிள் இந்த லாம்டாவுக்கு பதிலா நம்ம என்ன பண்ணிருக்கோம், a வை ரீப்ளேஸ் பண்ணுங்க. பிகாஸ் இந்த லாம்டா எங்க இருந்து வந்துச்சு, அப்ப லாம்டாவுக்கு பதிலா a வை கன்சிடர் பண்ணி ப்ரோசீட் பண்ணுங்க. ஹையர் ஆர்டர் போய்ட்டு ஃபைனல் ஸ்டெப்ல நீங்க திரும்ப மேட்ரிக்ஸ் சப்ஸ்டிட் பண்ணிக்கங்கன்னு சொல்றாரு. இட்ஸ் சாட்டிஸ்ஃபைட், ரைட்? இட்ஸ் வர்க்கிங், ரைட்? இட்ஸ் வர்க்கிங். So according to its conclusion, லாம்டாவுக்கு பதிலா நீங்க a வை ரீப்ளேஸ் பண்ணீங்கன்னா இங்க என்ன வரும், because each and every characteristic equation will satisfy its own matrix and matrix satisfies its own characteristic equation. According to that statement, a square minus 5 times of a minus, see, a is a matrix, a square is a matrix, but 4 is a constant. Can you consider constant now? No. I will want to multiply by unit matrix. Guys, sir, இது ஒரு characteristic equation. இதுக்குள்ள இருக்கிறது எல்லாமே ஒரு values. இப்போ அந்த வேல்யூஸ்க்கு பதிலா நான் என்ன சொல்றேன்னா இந்த வேல்யூஸ் இந்த மேட்ரிக்ஸ்ல இருந்தா கொண்டு வந்தீங்க இல்லையா, நான் என்ன சொல்றேன்னா அந்த வேல்யூக்கு பதிலா நீங்க மேட்ரிக்ஸையே சப்ஸ்டிட் பண்ணுங்க, ஏன்னா இதோட ரிலேஷன் தான் இது, ரைட் அப்படின்னு சொல்லிட்டு அப்ப இத நீங்க மேட்ரிக்ஸா மாத்துறீங்கன்னா இந்த லாம்டாக்கு பதிலா நீங்க மேட்ரிக்ஸை கன்சிடர் பண்றீங்க அப்படினா see that now A is called a matrix. So with the matrix I cannot consider a constant variable. ஒரு வேரியபிளை மட்டும் கன்சிடர் பண்ண முடியாது. அப்ப அந்த வேரியபிளை நீங்க மேட்ரிக்ஸா கன்வர்ட் பண்ணனும். If you want to convert any value, any arbitrary values into a matrix, you will have to multiply by unit matrix, right? So this is called Cayley-Hamilton theorem. இப்போ இதுல இருந்து நீங்க என்ன பண்ணீங்கன்னா find out the value of a square for an example. இப்போ क्वेश्चन என்ன கேக்குறாங்கன்னா for this given matrix you are requested to find out the value of a power 4. இதுதான் क्वेश्चन. நீங்க என்ன பண்ணுவீங்க a dot a dot a dot a dot னு போட்டு ஃபுல்லா சால்வ் பண்ணுவீங்க. அப்படி பண்ணாதீங்க அவர் சொல்றாரு. நான் இன்னொரு மெத்தட் கொடுத்திருக்கேன், ரைட்? you can go ahead with this procedure. இந்த procedure படி இதுல a squared வேல்யூ எவ்வளவு வரும்? a square is equal to 5 times of a minus 4 times of I. அது அப்படியே ரைட் சைடு பாஸ் பண்ணுங்க. 4 times of I. Just pass these two terms to the right side. Such that a squared value நீங்க ஃபைண்ட் பண்ணிட்டீங்களா? Yes. Now find the value of a power 4. இப்போ நீங்க a power 4 அப்படினா a power 4 நீங்க எப்படி ஃபைண்ட் பண்ணலாம்? a square dot a square வச்சு ஃபைண்ட் பண்ணலாமா? Yes. அப்ப இந்த ரெண்டு ஈக்குவேஷனை சப்ஸ்டிட்யூட் பண்ணுங்க. That is become what? 5a minus 4i 5a minus 4i into 5a minus 4i. ரெண்டுத்தையும் மல்டிப்ளை பண்ணுங்க. See, that is a square. See there, இப்போ ரெண்டுத்தையும் மல்டிப்ளை பண்ணீங்கன்னா 5a into 5a will become 25 times of a square minus, right? 4 into 5 will become what? Minus 20 times of a into I will become a only again, right? Next 5 into 4 again minus 20 times of a, because this 5a into this minus 5i, and then minus 4i will become minus into minus will become plus, 4 into 4 will become 16, I dot I will become I only, unit matrix, right? So what is the conclusion? Here I am getting 25 times of a square minus 20a will become minus 40 times of a plus 16 times of I. இப்படி எழுதிக்கலாம் அப்படி சொல்றாரு, right? Now here again we can reduce the equation further. our statement படி என்ன அப்படினா இந்த ஈக்குவேஷனை நீங்க further reduce பண்ணிக்கலாம். wait, I will write this matrix inside 1 0 I got 3 4. That's what I am considering. Let's proceed further, right? Now from this, anyway our answer is what? I am in need of a power 4, right? So now we got the expression for a power 4, but a power 4 எப்படி இருக்கு பாருங்க, a square ல இருக்கு. I got a power 4 equal to we can write a square dot a square, கரெக்ட்டா? a square வேல்யூ இங்க இருக்கு. அத நீங்க 2 டைம்ஸ் சப்ஸ்டிட்யூட் பண்ணி மல்டிப்ளை பண்ணீங்கன்னா ஃபைனலா எனக்கு என்ன வந்திருக்குன்னா 25 times of a square minus 40 times of a plus 16 times of I. That is the answer I got. Now here we also know 25 into a square can be again replaced by 5 times of a minus 4 times of I. Yes, minus 40 times of a plus 16 times of I should be equal to again 25 into 5 will become 125. Yes, 125 times of a minus 25 into 4 will become 100 times of I minus 40 times of a plus 16 times of I. So the next question is, see that 125 minus 40 that will give you 85. Yes, 85 times of a minus 100 minus 16 that will give you 84 times of I. Simply you can get this is equal to a power 4. Now you can substitute 85 into value of a is 1034 minus 84 into unit matrix is 1001. Finally, இப்போ நீங்க இத உள்ள மல்டிப்ளை பண்ணி ரெடியூஸ் பண்ணீங்க அப்படினா you will get the answer. Okay, anyway I will write the final answer also for your understanding. 84 ஆல உள்ள மல்டிப்ளை பண்ணீங்கன்னா that is 85 minus 84 will become 1. Next 85 into 0 will become 0. Here 84 into 0 will become 0 only. Next 3 times of 84 minus 84 into 0, it will be cancelled. See the 85 இது 3 ஆல மல்டிப்ளை ஆகும், இங்க 0 ஆல மல்டிப்ளை ஆயிட்டா இது 0 ஆயிடும். இத மல்டிப்ளை பண்ணா என்ன வரும்? That is become 15 240 255, right? I got 255. Next again I have to multiply by 4 times. Here this become 1 times, that is 84. But if I multiply it, right, so if the 4 times பண்ணீங்கன்னா என்ன வரும்? That will be 340. Yes, that is equal to 340, and here this become what? 340 minus 80 போட்டீங்க அப்படினா that is 260 254, right? So that is 256. I am getting 256. That is how we are getting final answer. That is see that a power 4. See, now big matrix போறதுக்கு பதிலா 4 steps, right? இன்னும் நம்ம மைண்ட்ல வச்சிட்டீங்களா? that is called a minus b into a minus b, a square minus b square, அப்படியே ஃபார்மட்ல ஒரே ஸ்டெப் ஆன்சர் கொண்டு வரலாம், right? So finally answer வந்ததுக்கு என்ன பண்ணலாம்? டைரக்ட்டா நீங்க மேட்ரிக்ஸ் சப்ஸ்டிட்யூட் பண்ணா getting the answer. இதுக்கு பதிலா a power 4 a dot a dot a dot a போட்டு 2 cross 2 3 மேட்ரிக்ஸ் 4 முறை போட்டு ஒண்ணுதையா மல்டிப்ளை பண்ணி கரெக்ட்டா ஆட் பண்ணி சப்ட்ராக்ஷன் பண்ணி லாஸ்ட் ஆன்சர் கொண்டு வரதுக்கு பதிலா doing blah 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 things simply we can bring the answer. That's the beauty of Cayley-Hamilton theorem. Like that you can also bring if it a power 4, if you want to find out the value of a power 8, now simply see that a power 4 க்கு ஆன்சர் தெரியும்ல, one step a power 4 dot a power 4 answer over. இது அப்படியே எடுத்து வந்து 2 டைம்ஸ் சப்ஸ்டிட் பண்ணீங்க அப்படினா அகைன் அதுக்குள்ள ஒரு a ஸ்கொயர் வரும். அந்த a ஸ்கொயருக்கு பதிலா திரும்ப இத சப்ஸ்டிட் பண்ணிக்கோங்க, you get the answer. It's over. Suppose a power 9 கேக்குறாங்கன்னா என்ன பண்ணுவீங்க, a power 8 dot a, it's over. a நீங்க ஃபர்ஸ்ட் क्वेश्चनலயே வச்சிட்டு இருப்பீங்க, a அப்படியே வச்சிட்டு ஃபர்ஸ்ட் a power 8 வேல்யூ சப்ஸ்டிட் பண்ணி மல்டிப்ளை பண்ணீங்கன்னா you get the answer. a power 8 நீங்க ஃபைண்ட் பண்றீங்களா, இத எடுத்து இங்க சப்ஸ்டிட் பண்ணீங்கன்னா you are getting a power 9. Clear? So that is how we are finding higher order matrix in a simplest way with the help of Cayley-Hamilton theorem. Clear? I hope things are very clear to you all. With this, your matrix is completely over. There are no other things to study here, right? Now we have to solve some numerous problems in order to demonstrate how easily your questions are from matrix. Okay, and some other properties are there for some matrix, right? நீங்க ப்ராப்பர்ட்டிஸ்லாம் வந்து பெருசா எதுவும் இல்லைங்க. ப்ராப்பர்ட்டிஸ்னா நான் ஒரு சில ப்ராப்பர்ட்டிஸ்லாம் நான் இங்கே எழுதிக்க மாட்டேன். அதெல்லாம் என்னன்னா அப்சர்வேஷன்ல இருந்து நீங்க எழுதணும். ஒரு ப்ராப்ளம் சால்வ் பண்ணும்போதோ இல்லை ஒரு டயக்னல் மேட்ரிக்ஸை பார்க்கும்போதோ அவங்க கொஸ்டின்லேயே கேட்பாங்க, அவங்க கேட்குற கொஸ்டினுக்கு அங்கேயே சால்வ் பண்ணும்போது உங்களுக்கு ஆன்சர் வந்துடும். You don't need to specifically segregate them and you don't need to memorize. இங்க நான் கொடுத்திருக்க ஸ்டேட்மெண்ட்ஸ் எல்லாம் in your examination you will be failed to understand which are the statement that I have given here. Rest of things statement will be given. ஒரு மேட்ரிக்ஸ் வந்து ப்ரூவ் பண்ண சொல்லுவாங்க, அதை நீங்க அப்படியே போட்டு பார்த்தாலே ஆன்சர். Let me prove it by solving the problems, right? Because question is very easy. So one small request, right? Please revise all the notes once again completely because tomorrow we have to solve many problems in matrix such that whichever the exam that we are going to face, matrix ல இருந்து questions இல்லாத பேப்பரே இருக்காது. நீங்க எந்த question பேப்பர்னா எடுத்து பாருங்க. ஏன்னா matrix that's very very important, and one more thing is its application is very vast. There are no things in this universe without matrix. எந்த ஒரு காம்போனன்ட் எடுத்தீங்கனாலும் அதுல நீங்க மேட்ரிக்ஸ் பார்க்கலாம், right? In the application point of view. Okay, with this I am concluding. This is all about matrix, right? Tomorrow we will solve problems and then we will start immediately our next chapter, right? If we can go with vector calculus or differential equation. If you have any other doubts you can ask in the group, right? Thank you all.